Welcome, gentle soul, to the sleepy professor's sanctuary of whispered knowledge. Here in this drowsy corner of the universe, curiosity moves like honey through warm air, and wonder walks on velvet feet beside the softest dreams. Tonight we invite you to float with us through the drowsy mysteries of space, where even the most magnificent explosions become lullabies for the weary mind. Our destination tonight lies in the sleepy dance of stellar fire, in the gentle storms that bloom like drowsy flowers across the face of our slumbering sun. Solar flares, whispered eruptions of light that sparkle and yawn across the surface of our star, sending sleepy ripples of energy drifting through the cosmic night, occasionally brushing against our world with the tender touch of aurora's dreamy fingers. Before we begin this peaceful wandering, I wonder, where has sleep found you tonight? Perhaps you are nestled deep within the embrace of soft pillows, your breathing already slowing to match the rhythm of rest. Maybe moonlight is painting silver dreams across your windowsill, and the night breeze is humming gentle lullabies through your curtains. Or perhaps dawn is still hours away, and you find yourself in that drowsy liminal space where thoughts drift like clouds across a sleepy sky. Wherever you rest, you are part of this quiet congregation of dreamers, each of us connected beneath the same drowsy canopy of stars, all sharing in this gentle exploration of cosmic slumber. If these sleepy wanderings bring comfort to your restless mind, I invite you to leave a gentle mark of kindness, a soft like or subscription that helps this dreamy space grow larger and more welcoming. To those who already rest here in this community of sleepy scholars, my gratitude flows like warm milk and honey. You are the reason these drowsy journeys continue to unfold, night after peaceful night. While my deepest wish is to guide you gently towards sleep's embrace, there exists the possibility that these stories might capture your attention a moment too long, like a particularly beautiful dream that resists the pull of deeper rest. Should that happen, consider it a gift of the universe. A night that offers both the treasure of rest and the jewel of knowledge, wrapped together in the soft blanket of contemplation. And for those whose hearts find joy in these sleepy explorations, I have opened another drowsy doorway called the Sleepy Geographer, where Earth's most peaceful landscapes are explored with the same gentle pace, the same whispered reverence. You can find that sanctuary waiting in the description below, whenever your dreamy curiosity calls. Now, let us begin this sleepy journey with a question that drifts soft as down. What hidden storms dream themselves into existence upon the drowsy face of our sun? What secret tempests gather, like sleepy clouds beneath its golden glow, waiting with patient drowsy intensity to bloom into gentle light? The sun's sleepy secrets. From our cozy vantage point here on Earth, wrapped in atmosphere thick as a warm quilt, the sun appears to be the most reliable of companions. Each morning it rises with sleepy faithfulness, stretching golden fingers across the drowsy landscape. Each evening it sets with quiet grace, painting the sky in soft pastels before settling into restful darkness. It seems as constant as a heartbeat, as peaceful as breath during deep sleep. But this perception, sweet and comforting though it may be, is like viewing a vast ocean from the safety of a distant shore. What appears calm and unchanging from afar is, in truth, alive with hidden currents, secret storms, and gentle turbulence that would humble even the mightiest earthly tempest. Beneath the sun's serene golden face, immense forces move like dreams within dreams, twisting and building with the slow patience of forming clouds. Invisible threads of magnetism weave themselves into intricate patterns, growing more complex with each passing moment, like a cosmic tapestry being woven by sleeping fingers. When these delicate patterns finally reach their limit, when the threads can no longer hold their graceful dance together, the stored energy releases itself in a burst as beautiful as it is powerful. A solar flare, a gentle explosion more potent than billions of earthly thunderstorms, yet somehow as peaceful as the first light of dawn. These stellar sighs remind us that even the most constant presence in our lives carries within it a hidden poetry of motion and change. Though they may sound fearsome when described in the language of science, solar flares possess a strange and drowsy beauty. They whisper to us that constancy and change are not opposites, but dance partners in the eternal waltz of existence. Like the steady rhythm of breathing during sleep, which occasionally deepens or quickens in response to dreams, our sun maintains its faithful presence while harboring secret storms that occasionally bloom into visible magnificence. Scientists observe these stellar dreams with instruments as sensitive as a parent, listening to a sleeping child's breath, ready to interpret every subtle shift and whisper. Sometimes these flares arrive as gentle ripples, barely disturbing the cosmic quiet. Other times they bring magnificent streams of charged particles that paint the night sky with shimmering curtains of aurora, turning the darkness into a gallery of living light. As we drift deeper into this sleepy exploration, we will examine solar flares from every dreamy angle, their peaceful beginnings in the sun's drowsy depths, their sudden awakening into brilliance, the echoes of great storms that once touched our planet like gentle giants, and the quiet vigilance of modern science as it keeps its sleepy watch over our stellar neighbour. The sun's drowsy heart. Our sun, for all its warmth and steadfast presence, is not the perfect sphere of tranquility that greets our drowsy eyes each morning. It is instead a vast nuclear heart, a glowing orb of plasma that moves with the slow grace of honey, the gentle persistence of tides, the endless patience of growing dreams. Deep within its core, in chambers of pressure beyond earthly imagination, hydrogen atoms press together with such intimate closeness that they surrender their individual existence and merge into helium, releasing energy that begins a journey lasting thousands of years. Like a message passed through countless sleeping hands, this energy slowly makes its way outward, rising through layers of stellar flesh until it finally emerges as the light and warmth that greets our world each dawn. This same energy that gives birth to morning and nurtures all life also stirs the sun's surface into ceaseless, gentle motion. The bright face you see in the sky is not solid ground but a restless ocean of plasma, a glowing sea of particles wrapped in invisible ribbons of magnetism that flow and dance like aurora made solid. These magnetic ribbons twist and weave as the plasma beneath them churns with the slow majesty of continental drift. Sometimes the ribbons break through the surface, forming dark patches called sunspots that appear as gentle blemishes against the golden glow. Though they look small to our distant eyes, many could cradle our entire Earth like a sleeping child. These sunspots are not wounds or imperfections, but gentle warnings, quiet harbingers of the storms stirring beneath the surface. These stellar moods follow a rhythm as predictable as seasonal change, yet as mysterious as the tides of dream. Approximately every 11 years, our sun grows restless, then peaceful again, like a great cosmic breathing cycle. During solar maximum, when activity reaches its sleepy peak, sunspots blossom across the surface like dark flowers in a golden garden, and flares burst forth with gentle frequency. During solar minimum, they fade away like morning mist, and the sun appears more serene, more deeply at rest. Every 11 years, something even more remarkable occurs. The sun's magnetic poles reverse completely, north becoming south, south becoming north, like a cosmic dance of polarity. It is a gentle reminder that change is woven into the very fabric of existence, that even the most fundamental forces participate in endless cycles of transformation. As you rest here in this moment, let your drowsy thoughts drift slowly outward, past the ceiling that shelters you, past the quiet air that surrounds you, beyond the gentle curve of Earth's atmosphere, and into the vast dreamy expanse where our sun burns with endless peaceful motion. To our eyes it appears calm and steady as a meditation bell, but viewed from the intimate distance of dreams, it breathes with gentle storms of fire, weaving light into the cosmic fabric with the patience of eternity itself. The birth of stellar dreams. The sun's heartbeat, though not perfectly regular like the ticking of a clock, follows a rhythm as ancient and reliable as the breathing of a sleeping giant. To truly envision the surface of our star is to imagine an environment of endless drowsy motion. Immense bubbles of plasma rise and fall like the slow breath of the cosmos itself, each one vast enough to swallow continents, yet gentle enough to shimmer like soap bubbles in afternoon sunlight before dissolving back into the golden sea. Above these luminous granules, great arcs of plasma loop outward into space like gossamer ribbons, glowing streamers that trace the invisible paths of magnetic fields with the delicate beauty of spider silk caught in morning dew. These magnetic fields stretch outward like the hidden architecture of dreams, delicate yet immense, shaping the star's restless crown with invisible hands. Sometimes these magnetic fields grow tangled and strained, like ribbons twisted by gentle wind. The tension builds slowly, patiently, with the inevitable progress of seasons changing. And when the stress can no longer be contained, when the cosmic patience finally reaches its limit, the fields snap back into simpler patterns with sudden grace, reconnecting in brilliant flashes of light that ripple outward like stones dropped in still water. Even in moments when no dramatic flares illuminate the cosmic stage, the surface itself lives and breathes, always shifting with the slow majesty of clouds crossing a summer sky, always changing, like the patterns of frost on winter windows, never quite the same from one heartbeat to the next, yet always maintaining its essential character, its fundamental identity as our sun. For countless centuries, human beings could only wonder at this hidden turbulence, like children pressing their faces against frosted windows, trying to glimpse the mysteries beyond. To ancient eyes, the sun was flawless perfection, a golden divine circle in the heavens, unmarked by blemish, untouched by change. It represented everything constant and eternal in a world of perpetual transformation. This perception held until the early 1600s, when the invention of the telescope gently pulled back the veil of distance. Astronomers like Galileo turned their curious eyes toward our star and discovered something that shook the foundations of cosmic understanding. Dark patches drifted slowly across the bright face like gentle shadows, sunspots, marks that proved our star rotated, that its light was not the unbroken perfection humanity had imagined for millennia. These discoveries did more than advance science. They transformed philosophy itself. The sun, ancient symbol of purity and unchanging eternity, revealed itself to be dynamic, restless, gloriously alive. It was a revelation that even the most constant presence could harbor beautiful mysteries, that perfection might lie not in unchanging sameness, but in endless, graceful variation. Today, with instruments as sensitive as the most delicate dreams, we see the sun in breathtaking detail that would amaze those early astronomers. Special spacecraft peer at our star through every wavelength of light, far beyond the narrow window that human eyes can perceive. Through ultraviolet and X-ray lenses, the golden circle transforms into something miraculous. A luminous, storm-filled furnace wrapped in tendrils of plasma like a cosmic garden blooming with fire. Vast arcs of energy climb into space and curl back upon themselves in graceful loops. It resembles less a simple orb and more like a restless ocean of light, constantly shifting between tranquility and gentle turbulence. Beyond the visible surface lies another drowsy mystery. The sun's outer atmosphere, called the corona, extends millions of kilometers into space like an invisible crown. Strangely, mysteriously, this corona burns far hotter than the surface below it. While the visible face of the sun glows at temperatures comfortable enough to nurture life at our distance, the corona blazes at millions of degrees, a puzzle that continues to intrigue scientists like a beautiful riddle whispered by the cosmos itself. Energy from tangled magnetic fields seems to funnel upward like invisible geysers, heating these outer reaches to temperatures that challenge our understanding. It is here, in this blazing crown invisible to our eyes, that the sun's storms are born. It is here that solar flares erupt and spread their gentle light throughout the solar system. This endless activity represents both gift and gentle challenge. Without the sun's ceaseless energy, life on Earth could never have begun its beautiful journey. Yet the same dynamic forces that sustain us can also reach across the cosmic void, brushing against our planet with influences that humble even our most sophisticated technologies. Satellites drift in altered orbits, power grids experience gentle disturbances, and the night sky blooms with auroras' ethereal curtains, all responses to the sun's changing moods. Here lies one of existence's most beautiful paradoxes. The same restlessness that nurtures life can, in extraordinary moments, disrupt it. Yet this disruption comes not as destruction but as reminder that we live within a vast, interconnected system where even the gentlest stellar sigh can ripple through space and time to touch our world. There is profound comfort in this knowledge, a peace that comes from understanding our place in the cosmic dance, to know that our star breathes with cycles and storms, that it experiences seasons vast and slow but no less real than Earth's gentle progression through spring, summer, autumn, and winter, gives the sun a strange intimacy. What appears as distant perfection reveals itself as dynamic presence, a neighbor whose hidden rhythms shape not only our days but our entire solar system. When you glimpse the sun through protective filters, when you catch sight of it painting morning gold across your walls, you are not observing something frozen in cosmic time. You are witnessing a living star, a celestial companion whose secret heartbeat influences every planet, every comet, every grain of cosmic dust within its vast sphere of influence. An eternal engine of light and gentle fire, carrying within its depths the delicate balance between creation and transformation, between the nurturing stability we depend upon and the dynamic change that keeps the universe alive. To understand this is to accept one of existence's most beautiful truths, that familiar constancy often masks the most profound mysteries. The stability, when examined closely, reveals itself to be not static perfection, but dynamic balance. Even the brightest, most reliable constants in our sky are at their core endlessly and beautifully restless. The moment of awakening. Now, let your imagination drift like morning mist toward the surface of our sun, not as the smooth golden circle that greets your drowsy eyes each dawn, but as it truly exists, a vast ocean of gentle fire, where waves of plasma rise and fall with the patient rhythm of cosmic breathing. Immense streams of charged particles flow and dance like aurora made liquid, while invisible magnetic fields weave themselves into patterns of increasing complexity, pulling and flexing with the slow grace of growing dreams. From our comfortable distance, wrapped in Earth's protective embrace, the sun appears as the essence of tranquility, a golden meditation bell hanging peacefully in the cosmic temple. But venture closer in your dreamy imagination, and you discover not calm, but magnificent restlessness. An ocean in perpetual gentle storm, endlessly beautiful, eternally alive, breathing with the deep rhythms of stellar existence. Peaceful events, the solar flare, these stellar dreams beginning in the sun's drowsy depths, stirring slowly toward wakefulness, then blooming into radiance that illuminates half the solar system. To understand how these cosmic flowers bloom, we must first understand the very essence of our sun. Unlike Earth with its solid ground and rocky foundations, our star consists almost entirely of plasma, matter in its fourth state of existence, beyond solid, liquid, and gas. Plasma forms when ordinary gas grows so warm that atoms themselves dissolve, surrendering their electrons like sleepy children releasing balloons into summer air, leaving behind a glowing soup of separated particles. Because these particles carry electrical charge, they cannot move with simple freedom. They respond intimately to magnetic fields, dancing always in partnership with invisible forces. Plasma does not merely flow like water or drift like air, it conducts electricity and magnetism on scales that dwarf earthly experience, creating a cosmic orchestra where matter and energy perform their eternal ballet. Imagine this ethereal dance as hot plasma circulates within the sun, rising and falling in convection patterns vast as continents. It carries magnetic field lines along like a gentle giant braiding cosmic hair. Picture invisible ribbons stretched through a slowly boiling cauldron of light, forever twisting, forever growing more complex, like the most intricate embroidery being sewn by patient, invisible hands. Over time, measured not in human heartbeats, but in the slow breathing of stars, these magnetic fields become increasingly distorted, knotted, strained almost to their breaking point. The tension builds with the inexorable patience of growing crystals, of mountains rising grain by grain, of flowers opening petal by petal, in perfect timing, and then arrives the moment of cosmic release. The tension transcends its limits. The magnetic field lines, stretched beyond endurance, snap back into new configurations with sudden, graceful violence. This is magnetic reconnection, the hidden engine that powers solar flares, as elegant in its physics as it is awesome in its consequences. Magnetic reconnection represents one of nature's most beautiful miracles, a process that can be described simply yet unleashes power beyond earthly comprehension. Imagine two opposing magnetic fields pressed against each other like cosmic dancers frozen in eternal tension. The pressure builds silently, invisibly, accumulating potential energy with the patience of geological time. Then, in a cosmic heartbeat, the resistance yields. The invisible lines of force break free from their standstill and reconnect in newer, simpler patterns. With this graceful rearrangement, tremendous energy floods outward like water bursting through a dam. On the sun's surface, magnetic reconnection never whispers. When tangled fields finally surrender to simplicity, the heavens ignite with gentle ferocity. Radiation bursts outward across every imaginable wavelength of light. Invisible waves ripple through space like cosmic music. Particles accelerate to breathtaking speeds, some racing close to light itself. Vast arcs of plasma lift majestically into the sun's corona, glowing like ribbons of molten starlight against the cosmic dark. The energy scale challenges human comprehension. A single robust solar flare carries the power of billions upon billions of earthly explosions, all released simultaneously in one magnificent cosmic sigh. Yet this tremendous release begins with something as simple as invisible field lines, those gossamer threads of magnetic force, finally relaxing from their complex knots into peaceful alignment. It resembles stretching a rubber band further and further until it finally slips free, snapping back with gentle violence. Only here, the rubber band spans distances measured in Earth diameters, and when it snaps, it illuminates half a star and sends tremors rippling through the entire solar system like cosmic church bells ringing across the void. Astronomers who witness these events describe them as simultaneously mesmerizing and essential to understanding our place in the cosmic order. Using special instruments that perceive X-rays and extreme ultraviolet light, they observe glowing loops of plasma, tracing the very architecture of magnetic fields with luminous precision. Before a flare awakens, these loops grow increasingly tight, twisting together like cosmic hair being braided by invisible fingers. Then, in a single transcendent moment, energy releases along the loops in brilliant cascades, and plasma erupts outward in elegant arcs that would humble earthly auroras. The entire spectacle can unfold within minutes, sometimes mere seconds. Cosmic tension transforms instantly into radiance. Magnetic stress becomes visible fire, silent pressure becomes luminous celebration. Yet this fundamental process extends far beyond our sun. Magnetic reconnection occurs throughout the universe, from the immediate vicinity of Earth to the most distant galaxies. Here at home, it happens within our planet's own magnetic shield, where particles from the solar wind slip inward, flowing down magnetic pathways into our atmosphere. The result manifests as auroras, those shimmering curtains of green and violet light that dance across polar skies. The same physics that drives solar storms paints our night sky with colors borrowed from cosmic fire. Scientists recreate reconnection in earthly laboratories within controlled chambers where artificial plasma reveals magnetism's hidden rules. The process plays a crucial role in humanity's quest for clean energy. In fusion reactors, where learning to guide plasma means mastering the same physics that powers stars, our sun simply performs this dance on a scale too immense for comfortable human comprehension. Often, solar flares birth themselves in the dark patches visible on the sun's surface, the sunspots that drift across the golden face like slow-moving storm systems. These regions earn the name active, because within their boundaries, energy coils like cosmic springs wound far beyond normal tension. The magnetic fields here bunch together, creating twisted loops and tangled arcs where stress accumulates with patient inevitability. Eventually, inevitably, these cosmic springs release their stored energy, and flares erupt outward into space like flowers blooming at the speed of light. The energy races away from the sun's surface, carrying with it the news of magnetic reconnection, spreading the story of stellar transformation throughout the solar system. From Earth's perspective, the visual drama depends entirely on how we choose to look. To unprotected human eyes, even a powerful solar flare might appear as nothing more than a subtle brightening, a gentle flash across the star's familiar face. But through the enhanced vision of X-ray telescopes, the view becomes breathtaking poetry written in light. Loops of plasma glow with fierce beauty. Arcs of stellar fire stretch into space like cosmic calligraphy, and shock waves ripple across the corona in expanding circles of pure radiance. A solar flare never manifests as a single beam or simple flash. Instead, it unfolds as a symphony of radiation, each wavelength carrying its own verse in the cosmic song. The plasma, heated by reconnection, surges to tens of millions of degrees, becoming, for brief moments, hotter than the sun's own nuclear core. Charged particles accelerate along magnetic highways that stretch outward into the solar system, like invisible roads connecting our star to every world within its influence. Some of these particles complete the journey to Earth in mere minutes, crossing 93 million miles of space to brush against our planet's magnetic field. When they arrive, they can gently disturb radio signals, cause satellites to drift slightly from their intended orbits, and trigger the protective protocols that keep spacecraft and their occupants safe from radiation. Other particles journey much farther, slipping away into the deeper reaches of the solar system, becoming tiny ambassadors of the sun's restless energy, carrying news of stellar storms to the outer planets and beyond, into the realm where our sun's influence gradually yields to the vast spaces between stars. Here, in contemplating this process, we encounter one of nature's most elegant teachings. Throughout the universe, in every corner and at every scale, nature seeks balance and harmony. On Earth, this drive toward equilibrium might manifest as a landslide settling a mountainside or lightning bridging the electrical difference between cloud and ground. On our sun, it appears as magnetic reconnection, complex knots of force suddenly unraveling, transforming tension into luminous celebration. What initially appears violent reveals itself as nature's method of restoration, finding simplicity and peace through temporary brilliance. The sun's most dramatic outbursts represent not cosmic anger, but cosmic healing, moments when accumulated stress resolves itself through bursts of radiant beauty. For scientists, The challenge lies in observing these flares as they unfold in real time. They happen swiftly, unpredictably, under conditions too extreme for earthly replication. This is why spacecraft like the Solar Dynamics Observatory and Parker Solar Probe hold such precious value. They orbit in patient vigil, recording every flicker of change, every ripple of plasma movement, documenting the sun's restless heartbeat so we can better understand and prepare for the ways stellar energy might reach across space to touch our technological civilization. Beyond measurements and instruments, beyond the dry language of scientific classification, there exists something deeply poetic in witnessing the birth of a solar flare. It humbles us to realize that even the mightiest star occasionally surrenders to its own tangled complexity, and that immense power can arise simply from the cosmic act of finding order within chaos. Every flare begins in perfect silence, as nothing more than invisible knots of magnetic tension hidden beneath the sun's bright surface. We cannot see the build-up, cannot anticipate the moment of release. Then, suddenly, the knot unravels, and our reliable star blazes with brief defiance, reminding us of the tremendous energy that flows through every corner of the universe, the dynamic forces that keep all creation dancing in the eternal ballet of existence. In those transcendent moments when solar flares bloom across the sun's face, we receive gentle reminders of our place within this vast, interconnected cosmos. We are not separate from the stellar drama unfolding 93 million miles away. We are participants in it, witnesses to it, children of the same cosmic processes that twist magnetic fields into knots and then release them in cascades of light. Every sunrise brings us energy that began as magnetic tension. Every day of warmth and light represents countless moments of cosmic reconnection, invisible healings happening within our star. The sun's gift to us is not just steady illumination, but the ongoing demonstration that even in the cosmos, complexity eventually surrenders to simplicity, chaos eventually resolves into harmony, and tension eventually transforms into the very light that makes life possible. The spectrum of stellar dreams. When a solar flare awakens from the sun's drowsy depths, it does not sing in only one voice or shine with a single color. Instead, it performs across the entire cosmic orchestra of light, broadcasting simultaneously in every conceivable wavelength, from the deepest bass notes of radio waves to the highest soprano of gamma rays. A grand performance that spans every octave of the electromagnetic spectrum, most of which remains invisible to our drowsy human senses. Yet through patient instruments we can hear every note of this stellar symphony. To truly appreciate this celestial music, we must first unfold the spectrum itself like a cosmic scroll. Visible light, that familiar rainbow of colors that paints our world in beauty, represents only the thinnest slice, a narrow window spanning roughly 400 to 700 nanometers in wavelength. Within this delicate range lies everything our eyes know how to see: the golden glow of candlelight, the silver shimmer of moonbeams on water, the rose and amber of sunset, the deep blue of twilight skies. Yet to our sun, this visible light forms merely one instrument in an infinite orchestra. During a flare's awakening, our star sings simultaneously in every possible note, from the lowest rumble to the highest whisper, creating a cosmic symphony that spans scales beyond earthly music. At the spectrum's gentle foundation lie radio waves, the giants of electromagnetic radiation, stretching for kilometers in length like cosmic ocean swells. When a flare blooms on the sun's surface, enormous bursts of radio energy flood outward into space, sometimes persisting for minutes, sometimes hours, like the lingering notes of a cosmic bell that continues resonating long after being struck. These radio signals carry tremendous power, strong enough to overwhelm earthly transmissions, gently disrupting navigation systems and communication networks. Yet to scientists, these disruptions represent treasured gifts of knowledge. Radio bursts reveal how charged particles accelerate through the sun's atmosphere, how plasma waves ripple through the stellar crown. It is as though the sun speaks to us in cosmic static, translating its hidden storms into voices our instruments can capture with great metallic dishes turned skyward in patient listening. As we climb higher through the spectrum's invisible ladder, we encounter microwaves and infrared radiation. These wavelengths may not dazzle with aurora's visible glory, but they carry within themselves the thermal story of each flare, the gentle narrative of how stellar plasma cools and settles after the storm. Telescopes tuned to these wavelengths allow researchers to measure temperatures with exquisite precision, to observe the way solar fires bank and fade like cosmic embers cooling in the stellar breeze. Though invisible to our organic senses, these thermal whispers form vital pieces of the solar puzzle, quiet threads woven through the tapestry of our star's behavior, helping us understand not just the dramatic moments of eruption, but the peaceful interludes of recovery that follow. Finally, after wandering through the hidden spectrum, we return to the light we know most intimately, visible radiance, the gentle glow that greets our eyes each morning and bathes the landscapes of Earth in warmth and color. When exceptionally powerful solar flares erupt, they can actually brighten the sun's surface itself, creating what astronomers call white light flares. These visible brightenings appear rarely, like cosmic fireflies flickering against the golden background of our star. When they do manifest, they remind us that solar storms need not always hide in invisible wavelengths. Sometimes, even to human eyes, our sun announces its restless moods through bursts of enhanced radiance that can, with proper protective filters, be glimpsed directly from Earth. Long before spacecraft or digital sensors existed, 19th century astronomers with modest telescopes recorded these sudden flashes of visible light. They could not yet explain their cause or predict their occurrence. To those patient observers, the bursts appeared like sparks thrown upward from a cosmic bonfire, each one alive with mystery and beauty. Imagine those dedicated astronomers pausing at their instruments, surprised and delighted to witness their supposedly perfect sun flickering with such fierce vitality. In that age of discovery, those visible sparks represented glimpses of a profound truth only later revealed, that our sun is not serene, but gloriously restless, always concealing storms beneath its peaceful glow. Beyond the visible, the spectrum deepens into realms our eyes cannot touch, wavelengths that exist in the borderlands between the familiar and the mysterious. Next comes ultraviolet, a strange band of radiation that hovers between light and energy, half familiar yet half dangerous, like twilight existing between day and night. Solar flares produce tremendous floods of ultraviolet radiation that pour into the sun's atmosphere and beyond. These energetic photons strike and heat surrounding gases, stirring them until atoms ionize, breaking apart and reshaping the delicate balance of the stellar environment. Earth, fortunately, possesses its protective atmospheric shield, which absorbs most harmful ultraviolet high above us, safeguarding life from damage while simultaneously hiding this invisible drama from ground-based observation. To witness the sun's ultraviolet performance, we must rely on telescopes orbiting beyond our atmosphere's protective embrace. What these instruments reveal defies earthly imagination. In ultraviolet wavelengths, our familiar golden sun transforms into a luminous tapestry of flowing energy, a writhing fabric of loops, arcs and brilliant knots of plasma that dance with ethereal beauty. During a flare's awakening, this cosmic tapestry glows more intensely, as though someone had struck a great gong of light and set the entire stellar atmosphere vibrating in harmonious resonance. These ultraviolet surges do not remain trapped near the sun. They ripple outward at light speed, eventually reaching Earth where they reshape our planet's ionosphere, subtly altering the propagation of radio signals, gently disturbing GPS accuracy, and pulling at the invisible threads that connect our modern technological civilization. It represents a humbling reminder that invisible light carries real consequences, that the storms of a distant star can travel down into our maps, our signals, the electronic voices that weave our global community together into a functioning whole. Ascending higher still along the spectrum's energy ladder, we encounter X-rays, the unmistakable signature of solar flare activity. Here lies the realm where magnetic reconnection announces itself most clearly. X-rays indicate that reconnection has accelerated particles to incredible speeds, sending them crashing into denser layers of the sun's atmosphere with tremendous energy. These high-energy collisions create bursts of X-ray radiation that spacecraft in Earth orbit detect almost instantaneously. Satellites in the GOES family maintain constant vigilance, measuring every subtle fluctuation in X-ray brightness, like cosmic physicians monitoring the sun's vital signs. These instruments categorize flares using a deceptively simple system of letters, C, M, and X. To casual observation, this might appear as merely dry scientific classification, but behind those letters lies urgent practical purpose. Each flare, each sudden increase in X-ray output, carries a message that space weather is stirring. Airlines adjust flight paths, power companies prepare their grids for potential disturbances, and satellites activate protective protocols. What manifests as invisible flashes in the cosmic depths can, within minutes, ripple through the technological infrastructure of human civilization. At the extreme upper end of the electromagnetic spectrum dwell gamma rays. Light at its most concentrated and explosive, these photons appear only when solar processes accelerate particles to near relativistic speeds, creating conditions so extreme they rival the most violent events observable anywhere in the universe. Gamma rays from solar flares are rare, fleeting, often lasting no longer than the blink of a sleepy eye. Detecting them requires instruments of extraordinary sensitivity, many of which also study the gamma-ray bursts from distant galaxies, those cosmic explosions that announce the deaths of massive stars in realms so distant. Their light has traveled billions of years to reach us. That our own gentle sun can generate such ferocity places it among the universe's most powerful engines of energy, a humbling reminder that even our familiar neighborhood star participates in the same extreme physics that governs the most distant and exotic cosmic phenomena. For scientists studying solar behavior, the complete spectrum of a flare reads like a cosmic book written in multiple languages. Radio waves tell stories of plasma movements and particle acceleration. Ultraviolet radiation reveals the heating and ionization of stellar atmosphere. X-rays speak of high-energy collisions and magnetic field dynamics. Gamma rays whisper secrets of the most extreme physical conditions achievable in nature. Together, these wavelengths form a complete narrative, allowing researchers to piece together the complex story of how invisible magnetic stress transforms into visible cosmic celebration, how stellar tension becomes universal light, how the hidden becomes magnificently apparent across every possible frequency of electromagnetic radiation. It grows easy to forget, while resting beneath a soft blue sky or gazing up at a tranquil canopy of stars, that we exist in constant connection with a star whose storms span this vast range of energy and influence. A solar flare is never simply seen or merely detected. It is felt throughout our technological systems, witnessed in our communication networks, celebrated in the shimmering aurora that dance across polar skies. Ancient peoples knew the sun as steady and singular, a golden disk without variation or complexity. Modern instruments have revealed it as a cosmic orchestra, broadcasting continuously in hidden voices across every wavelength of light, conducting an endless symphony of electromagnetic radiation that reaches into every corner of the solar system. There exists profound poetry in understanding solar flares, not as sudden disruptions, but as moments when the cosmic orchestra plays all its instruments simultaneously at maximum volume. Radio waves provide the deep, resonant percussion. Ultraviolet contributes quicksilver strings. X-rays offer bright brass fanfares. Gamma rays add piercing flute notes that sound only during the most dramatic crescendos. Our sun conducts this music continuously, and we, equipped with our sensitive telescopes and detectors, serve as an audience leaning forward in cosmic appreciation, straining to hear every nuance of this stellar performance that never truly ends. Perhaps the most humbling realization is that this grand performance continues whether we listen or not. Small flares spark daily, like the orchestra warming up before the main event. Medium flares surge every few weeks or months, providing full movements in the cosmic symphony. Great flares roar perhaps once or twice per solar cycle, delivering crescendos that resonate throughout the solar system. Each represents a reminder that our star possesses a restless, creative heart that never stops composing new music, broadcasting its stellar dreams across the electromagnetic spectrum in an eternal concert that connects every world within its gravitational embrace. Through this spectrum of light, scientists have learned not only about our own sun, but about countless other stars scattered across the cosmic deep. The same physics repeats itself in distant galaxies, in glowing nebulae where new stars are born, in ancient stellar clusters that have danced together since the universe's youth. By listening carefully to our sun's electromagnetic symphony, we hear echoes of the entire cosmos, learning the universal language that all stars speak when they dream their fiery dreams. What appears as a single golden light in our daytime sky reveals itself, through patient observation, as a magnificent performance woven through every possible octave of radiation, ceaseless and filled with wonder beyond human measurement. To witness a solar flare across the full spectrum is to see light wearing all its possible costumes, painting across invisible canvases, carrying stellar energy outward on wings of pure electromagnetic poetry. It teaches us that even the most familiar star continues hiding depths we have barely begun to explore, singing songs in frequencies we are only learning to hear, conducting cosmic orchestras whose music shapes the very fabric of our solar system's existence. The language of stellar moods. Just as light itself manifests in countless voices across the electromagnetic spectrum, so too do solar flares themselves appear in an endless variety of forms and intensities. They are not uniform eruptions, not simple cosmic sighs. Instead, they vary dramatically in size, duration, and power, like a stellar musician capable of producing everything from the gentlest whisper to the most thunderous crescendo. Some flares barely disturb the sun's peaceful surface, flickering so softly they resemble candles wavering in a distant window. Others surge with such tremendous force that their influence ripples throughout the entire solar system, strong enough to shake the magnetic shields of worlds far from the sun's warming embrace, powerful enough to paint aurora across the skies of planets we have never visited. To bring order to this apparent chaos of stellar temperament, scientists developed a classification system as elegant as it is essential, a simple arrangement of letters that has become the universal language for describing the sun's moods: C, M, and X. These letters appear straightforward on paper, almost casual in their simplicity, yet they represent doorways into understanding the most powerful natural explosions accessible to human observation. At the gentle foundation of this scale rest the C-class flares, the sun's quiet murmurs and drowsy sighs. These represent the star's normal conversational tone, frequent and peaceful, sometimes occurring daily like the regular breathing of a sleeping giant. They remind us that even when the solar surface appears perfectly calm to our distant observation, currents of plasma continue their eternal dance beneath the golden facade, occasionally releasing small bursts of stored magnetic energy. Most C-class flares pass unnoticed by Earth's technological systems, causing only the subtlest disturbances in our planet's upper atmospheric layers. They brush gently against radio signals before fading back into cosmic background noise, like whispered conversations in a distant room. Yet these quiet events serve a vital purpose in the solar cycle, releasing small amounts of accumulated stress, preventing larger buildups of magnetic tension. To solar physicists, C-class flares represent the sun's baseline activity, proof that our star never truly rests, never falls completely silent. They are the cosmic equivalent of a cat's purring, gentle vibrations that indicate contentment and life, reminders that steady energy flows through every layer of our stellar companion. Ascending the scale, we encounter M-class flares, the middle voices in the sun's emotional range. These events carry 10 times more energy than their C-class cousins, making them impossible to ignore when they bloom across the solar surface. They possess sufficient power to disrupt high-frequency radio communications near Earth's magnetic poles, to spark more vivid displays of aurora, to serve as cosmic early warnings that our star's energy is building towards something more dramatic. M-class flares often arrive in clusters, like the opening notes of a symphony, gradually building toward its main themes. Solar observers pay careful attention to these events, not just for their immediate effects, but for what they might herald. When M-class activity increases, it frequently signals that the sun's magnetic fields are growing more tangled, more stressed, more likely to produce the spectacular releases that define the scale's upper reaches. These moderate flares create noticeable but manageable effects on Earth. Airline pilots flying polar routes receive advisories about increased radiation levels. Satellite operators monitor their spacecraft more carefully. Radio operators in high latitudes experience temporary blackouts. Yet M-class flares also bring gifts in the form of enhanced aurora, painting the polar skies with more vibrant colors, extending the dancing lights to slightly lower latitudes where more human eyes can witness the cosmic display. And then, at the pinnacle of solar fury, dwell the X-class flares. These represent explosions so immense that the classification system itself becomes inadequate to contain them. Unlike C and M classes, which have defined upper limits, the X-class extends infinitely upward. An X1 flare already possesses staggering energy. An X10 carries 10 times that power. An X20 doubles the intensity again. The sun has, on rare but memorable occasions, produced flares so overwhelming that our most sensitive instruments have been saturated, blinded by the sheer magnitude of electromagnetic radiation flooding toward Earth. X-class flares demand respect and careful preparation. Without Earth's protective magnetic field to shield us, direct exposure to one of these stellar storms could prove life-threatening to unprotected humans. Astronauts working beyond our atmosphere's safety must rely on careful scheduling, radiation monitoring, and protective shelters during periods of high solar activity. Yet despite their intimidating power, X-class flares represent invaluable opportunities for scientific discovery. They provide moments when the physics of plasma and magnetic reconnection reveal themselves on scales impossible to reproduce in earthly laboratories. They transform the sun into nature's own particle accelerator, allowing researchers to study phenomena that push the boundaries of our understanding. Throughout recorded history, several extraordinary flares have carved themselves into human memory with particular vividness. One of the most famous erupted on November 4, 2003, during a period of intense solar activity that astronomers remember as the Halloween storms. This particular flare overwhelmed the X-ray detectors aboard monitoring satellites, saturating their sensors with more radiation than they were designed to measure. Later analysis suggested the event reached at least X28 classification, possibly even stronger. Such numbers strain comprehension, representing energy releases equivalent to billions of nuclear explosions occurring simultaneously across a region larger than Earth itself. The associated particle storm raced through the solar system, disrupting satellite operations, forcing airlines to reroute flights away from polar regions to protect passengers and crew from radiation exposure, and painting aurora as far south as the Mediterranean Sea. Another memorable outburst occurred in March 2012 during solar cycle 24, classified as X5.4 Karma. It was not the strongest flare on record, yet it reminded the world how swiftly our sun can transform from apparent tranquility to magnificent fury. Within minutes, what had been a peaceful stellar surface erupted in brilliant violence, demonstrating that even during seemingly quiet periods, the sun carries within itself the potential for sudden dramatic change. Even more sobering was the solar storm of August 1972, which occurred between the Apollo 16 and Apollo 17 missions. A powerful flare and its accompanying particle storm flooded the inner solar system with dangerous radiation. Had astronauts been traveling to the moon at that time, they would have been caught outside Earth's protective magnetic shield, exposed to radiation doses that could have proved fatal. Only fortunate timing prevented tragedy, but the event served as a stark reminder that human exploration beyond Earth's protective embrace must always account for our star's unpredictable moods. Future missions to Mars, to asteroids, to the outer planets must all incorporate sophisticated space weather forecasting to ensure crew safety during periods of enhanced solar activity. Perhaps most famous of all is the Carrington event of 1859, named after astronomer Richard Carrington, who observed with his modest telescope a sudden burst of white light flaring across the sun's surface. Neither he nor his contemporary Richard Hodgson, who witnessed the same event independently, could have imagined the consequences of what they had observed. Within 18 hours, the flare's effects reached Earth with unprecedented intensity. Telegraph systems across North America and Europe sparked, failed, and in some cases caught fire. Telegraph operators received electric shocks from their equipment. Yet the storm also brought unprecedented beauty in the form of aurora displays visible as far south as the Caribbean, Hawaii, and parts of Africa. Miners in the Rocky Mountains reportedly woke thinking dawn had arrived. So bright were the aurora dancing overhead. The Carrington event remains the most powerful documented space weather event in recorded history. Though we cannot assign it precise classification using modern instruments, evidence suggests it represented an X-class flare of extraordinary magnitude, possibly X45 or even stronger. It serves as both warning and reminder that our sun is capable of surprises that echo across centuries. These historical storms illuminate two fundamental truths about our relationship with solar activity. First, while our sun often moves in predictable cycles and patterns, it remains capable of sudden extreme outbursts that can exceed all previous experience. The universe does not guarantee that future solar storms will remain within the bounds of past observations. Second, our technological civilization has become increasingly vulnerable to space weather effects. The telegraph networks that failed during the Carrington event pale in comparison to the satellite constellations, power grids, internet infrastructure, and GPS systems that now form the nervous system of modern society. A Carrington-level event occurring today would likely cause disruptions far more extensive than anything witnessed in the 19th century. Yet this vulnerability also drives innovation and preparation. Space weather forecasting has evolved into a sophisticated science, with dedicated spacecraft monitoring the sun continuously, advanced computer models predicting storm arrival times, and international cooperation ensuring that warnings reach all potentially affected systems. The classification system of C, M, and X flares provides more than academic organization. It creates a common language for space weather alerting, allowing scientists, engineers, and emergency managers to communicate clearly about solar threats. When space weather forecasters issue an X-class flare alert, every relevant industry knows immediately what level of preparation and protection to implement. Airlines adjust flight paths to reduce radiation exposure. Power companies prepare their grids for potential geomagnetic disturbances. Satellite operators place their spacecraft in safe modes. Radio enthusiasts expect communication blackouts. Aurora photographers prepare their equipment for spectacular displays. This systematic approach to understanding and responding to solar activity represents one of humanity's most successful adaptations to cosmic forces beyond our control. We cannot prevent solar flares or modify their intensity, but we can observe them carefully, understand their behavior, and prepare for their effects with increasing sophistication. As you rest here in this moment, perhaps gazing up at stars beginning to emerge in the darkening sky, remember that one of those lights, hidden now by Earth's rotation, follows its own complex schedule of activity and rest. Sometimes it whispers gently in C-class murmurs, sometimes it speaks clearly in M-class announcements. Occasionally it roars in X-class proclamations that ripple through the entire solar system. Each category represents not just scientific measurement, but a different mood in our star's vast emotional range, a different verse in the cosmic song it sings continuously across the electromagnetic spectrum. Understanding these moods helps us live more safely and more wisely as technological beings orbiting a dynamic, unpredictable, magnificently alive star. The next time you hear mention of solar flare classifications, remember that those simple letters carry within them stories of cosmic drama, scientific discovery, technological adaptation, and the endless dance between humanity and the restless star that gives us life. They represent our growing ability to listen to the sun's language, to understand its moods, and to prepare for the ways its stellar dreams might occasionally reach across space to touch our small, precious world. Whispers from the cosmic deep. As our drowsy journey through the mysteries of solar flares draws toward its gentle conclusion, let us drift one final time into the vast quietude of space, where these stellar dreams travel on invisible currents, carrying with them stories of magnetic reconnection and cosmic transformation. Every flare that blooms upon the sun's surface sends ripples through the fabric of space itself, like stones dropped into a perfectly still pond. These ripples travel outward at the speed of light, crossing the 93 million miles to Earth in just over 8 minutes, then continuing their journey into the deeper reaches of the solar system, carrying news of our star's restless moods to distant worlds we may never visit. When these cosmic messengers finally reach our planet, they interact with Earth's own magnetic field in ways both subtle and spectacular. Our world possesses its own gentle magnetosphere, an invisible shield that deflects most of the solar wind's charged particles, protecting the delicate atmosphere that nurtures all life. Yet during powerful flares, this shield itself begins to sing, vibrating like a cosmic bell struck by stellar energy. The results manifest as some of nature's most beautiful phenomena, aurora borealis and aurora australis, those ethereal curtains of light that dance across the polar skies, represent the visual poetry of solar flare interactions with our magnetic field. Green and violet ribbons undulate against the star-filled darkness, created when solar particles follow magnetic field lines down into our upper atmosphere, exciting oxygen and nitrogen atoms until they glow with ethereal radiance. To witness aurora during periods of high solar activity is to see the universe painting with light itself, using the entire night sky as its canvas, creating masterpieces that exist for moments before dissolving back into cosmic silence. These displays remind us that we are not separate from the stellar drama playing out millions of miles away, but participants in it, witnesses to the endless conversation between our sun and our world. Scientists continue their patient vigil, watching our star through the eyes of spacecraft that never blink, never sleep, never lose focus on the solar surface where the next flare might awaken at any moment. The Solar Dynamics Observatory captures images of breathtaking beauty and scientific precision every few seconds, creating movies of stellar evolution that compress hours of solar activity into minutes of human observation time. The Parker Solar Probe, humanity's most ambitious solar mission, actually flies through the sun's outer atmosphere, sampling the very plasma that gives birth to solar winds and flares. It represents our species' most intimate encounter with stellar fire, a technological achievement that would have seemed like fantasy to the astronomers who first glimpsed sunspots through primitive telescopes. These missions, along with others from space agencies around the world, weave together an increasingly detailed understanding of how our star works, how it breathes, how it dreams its magnetic dreams into visible reality. Each new observation adds another piece to the cosmic puzzle, another verse to the solar song we are slowly learning to hear and understand. Yet, for all our scientific progress, for all our sophisticated instruments and detailed measurements, the sun retains its essential mystery. We can predict some aspects of its behavior, classify its flares, measure its magnetic fields, but we cannot control or substantially alter its fundamental nature. It remains what it has always been, a nuclear furnace of unimaginable power, following its own ancient rhythms, dancing to cosmic music we are only beginning to comprehend. This humility before the vast forces of nature brings its own form of peace. In acknowledging our small place within the solar system's grand design, we find comfort in belonging to something larger than ourselves. The same stellar processes that create solar flares also created the heavy elements necessary for rocky planets, for oceans, for the complex chemistry that eventually gave rise to life itself. We are, quite literally, children of stellar fire. The calcium in our bones, the iron in our blood, the oxygen we breathe, all were forged within the hearts of ancient stars and scattered across space by cosmic processes similar to those we observe in solar flares today. Every atom in our bodies carries within it the memory of stellar dreams, the echoes of cosmic reconnection events that occurred billions of years before Earth itself existed. This connection extends beyond poetic metaphor into physical reality. The sun's 11-year activity cycle influences Earth's climate in subtle ways. Solar flares affect the chemistry of our upper atmosphere. The solar wind shapes the boundary between our solar system and the vast spaces between stars. We exist not as isolated beings on an isolated world, but as integral parts of a dynamic system that extends from our star's nuclear core to the outer reaches of its gravitational influence. Understanding this interconnection brings both responsibility and wonder. Responsibility to continue monitoring space weather, to protect our technological infrastructure from solar storms, to prepare for the possibility that our star might someday surprise us with flares more powerful than any we have yet experienced. Wonder at the intricate beauty of cosmic relationships, at the elegant physics that governs stellar behavior, at the remarkable coincidence that placed our world at precisely the right distance from a star whose energy output remains stable enough to nurture life, yet dynamic enough to create the complex magnetic phenomena we call solar flares. As Earth rotates and our sun disappears beyond the western horizon, remember that its absence is merely an illusion of perspective. The star continues its restless dance, continues weaving magnetic fields into complex patterns, continues building toward the next flare that will paint space with invisible light and send gentle ripples through the cosmic medium that connects all worlds within its embrace. Somewhere on the sun's hidden hemisphere, magnetic field lines may be twisting toward their breaking point at this very moment. Somewhere in the stellar plasma, energy is accumulating like water building behind an invisible dam. Somewhere in the sun's corona, the next solar flare is preparing to announce itself to the cosmos, with a burst of radiation that will cross space at light's own speed, carrying with it the news of stellar transformation. When that moment comes, when magnetic reconnection transforms stored energy into radiant celebration, particles will race outward along invisible highways, some destined for Earth, others bound for Mars, Jupiter, Saturn, and the distant realms where our solar system gradually yields to the spaces between stars. These cosmic messengers will carry within their motion the signature of events happening now on our sun's surface, the fingerprints of magnetic fields that twisted and snapped back into simpler configurations, the echoes of a stellar sigh that began as invisible tension and bloomed into visible fire. In time, some of these particles may slip through Earth's magnetic shield and spiral down into our atmosphere, where they will collide with oxygen and nitrogen atoms and cause them to glow with the ethereal colors of aurora. In those moments of dancing light, we will witness the completion of a cosmic journey that began with invisible magnetic stress on the surface of our star and ended with visible beauty painting across the night sky of our world. This eternal cycle of stellar energy, cosmic travel, and atmospheric display continues, whether we observe it or not, whether we understand it or not, whether we sleep or wake. It represents the universe's own heartbeat, the rhythm of electromagnetic forces that bind together not just our solar system, but galaxies, galaxy clusters, and the vast web of matter and energy that extends across all of space and time. As you drift towards sleep's gentle embrace, carry with you this knowledge of cosmic connection. The same forces that create aurora also created the elements necessary for life. The same magnetic processes that drive solar flares also protect our planet from cosmic radiation. The same star that occasionally disturbs our satellites and power grids also provides the steady energy that drives weather patterns, ocean currents, and the photosynthesis that fills our atmosphere with breathable oxygen. We live within a cosmic dance of extraordinary complexity and beauty, where stellar dreams become visible light, where magnetic tension transforms into atmospheric splendor, where the restless energy of our sun weaves itself into the very fabric of existence on Earth. In this understanding lies both science and poetry, both knowledge and wonder, both the precision of careful measurement and the joy of cosmic belonging. Sleep well in the knowledge that you are part of this magnificent tapestry, a conscious witness to the endless creativity of a universe that transforms simple elements into stars, stars into light, light into life, and life into the awareness capable of contemplating its own cosmic origins. The solar flares will continue their ancient dance long after human civilization has transformed into something unimaginable. Stars will keep converting magnetic stress into radiant energy. Light will keep crossing the void to paint aurora across the skies of distant worlds. The universe will continue its eternal conversation between order and chaos, simplicity and complexity, rest and transformation. And in that eternal dance, in that cosmic rhythm that began billions of years ago and will continue billions of years hence, we find our place not as outsiders looking in, but as participants in the grand symphony of existence, children of stellar fire, awakening to conscious appreciation of the forces that created us and continue to shape our world with every passing moment. Sweet dreams, fellow travelers in this cosmic ocean. May your rest be deep and peaceful, and may your dreams be filled with the gentle light of distant stars, the ethereal dance of aurora, and the quiet knowledge that you belong to a universe more beautiful and interconnected than any earthly imagination could conjure alone. The sun will rise again, as it has for billions of mornings, carrying within its golden light the energy of countless magnetic reconnection events, the gentle power of stellar dreams made manifest as the warmth and radiance that greets each new day. And somewhere in its depths, new flares are already stirring, preparing to continue the ancient conversation between our star and the cosmos that surrounds us all. And yet, beyond the practical, there is something beautiful in this system of letters and scales. They transform what could feel like incomprehensible chaos into something familiar, a family of events with names, with identities, each one a chapter in the sun's restless story. The letters C, M, and X may be simple, but they hold within them tales of sparks and storms, of instruments strained to their limits, of auroras painted across unexpected skies. To think of flares as a family is to see the diversity of a star's moods, from the softest whispers to the greatest tempests. Each plays a role in shaping the story of the sun, and together they remind us that we live not beside a lamp, but beside a breathing, changing, living star. But when the sun grows restless, its fury does not end with the brilliance of flares. Sometimes it exhales with far greater force, not just light, but matter itself. Great, rolling clouds of plasma, immense storms of charged particles hurled into space. These are called coronal mass ejections, or CMEs. If flares are the quick sparks of brilliance, CMEs are the vast waves that follow, sweeping outward like tides. Together, they form a pair of cosmic companions, sparks and storms, light and matter, shaping the space weather that reaches across the solar system. It is easy to confuse them, for they often arrive together, yet they are not the same. A flare is a cry of light, a sudden shout across space, reaching Earth in just 8 minutes, carried at the speed of light itself. A CME is slower, heavier, less like a shout, and more like a fist, carrying billions of tons of plasma into the void. Depending on its speed, it may arrive in a single day or take several, its storm of particles lingering as it washes over Earth's magnetic field. Where the flare dazzles, the CME endures. Where the flare flashes, the CME presses steadily, reshaping our skies for hours or even days. Both are born of tangled magnetism. Invisible lines wound tight until something must give, and when they occur together, their effects are magnified. First the flare announces itself in light, then the CME arrives with substance, a 1-2 rhythm of disruption. The distinction becomes clear only when you step back to listen for timing. The flare is the flash, the CME is the storm that follows. Both are the sun's breath, both are the sun's voice. The scale of a CME is staggering. Imagine not a cloud of vapor, nor a storm of rain, but a vast and heavy cloud of plasma, a luminous tide of charged particles, its mass measured not in drops or pounds, but in billions upon billions of tons. This storm is hurled outward by the restless star, pushed into the void at speeds that dwarf any storm or wind we know on Earth. And the cloud does not remain small. It expands and expands again, ballooning outward until its body becomes larger than the star itself, stretching wider than the orbit of planets, swelling into a structure so immense it is difficult to comprehend. These clouds can span millions of kilometers across, carving through the ever-present solar wind like tidal waves rolling across a cosmic sea. They do not travel empty-handed. Wrapped within them are twisted coils of magnetic fields, fragments of the sun's own restless heart, carried outward like tangled threads unraveling into space. When such a cloud collides with Earth's magnetic shield, something remarkable happens. Those wandering magnetic fields meet our planet's own, and in that contact they can reconnect, merge, and transfer their energy. It is like two rivers crashing into one another, currents mixing and surging, setting off geomagnetic storms that ripple invisibly around the globe. For us on the ground, the effects of these storms exist on a spectrum that ranges from the profoundly beautiful to the quietly troubling. On the beautiful side, CMEs give rise to the auroras, shimmering curtains of color that ripple across the polar skies. Green, red, violet, and deep indigo light spilling across the heavens, weaving and dancing as if the sky itself has become a living fabric. On rare occasions when the storm is especially strong, these lights spill far beyond their polar homes, appearing in skies where people may never have expected to see them. To witness an aurora far from the poles is to glimpse the hidden connection between Earth and its star, revealed in luminous strokes. On the troubling side, these same storms stir our technologies. The currents they induce can snake silently through long power lines, overwhelm satellites, and scramble radio communication. In extreme cases, the disruption is far from subtle. In March of 1989, a geomagnetic storm triggered by a CME collapsed Quebec's power grid in Canada, plunging millions into sudden darkness. What to most of the world was a night of extraordinary auroras was, for those in the dark, a reminder that even our most advanced systems remain vulnerable to the moods of the sun. And part of what makes CMEs so challenging is their unpredictability. Scientists can watch the sun, can track the restless regions on its surface, can note when a flare erupts, but predicting whether a CME will follow is far less certain. Sometimes they arrive hand in hand with flares. Other times, a flare shines brilliantly but leaves no cloud behind. And even when a CME is launched, it does not always aim toward Earth. Many drift harmlessly away, sweeping into deep space with no effect at all. But when one is directed squarely at our planet, then attention sharpens. By studying the magnetic skeleton within CMEs, researchers try not only to forecast when they will arrive, but also how severe they may be. This remains one of the great challenges of space weather science, to look at the tangled knots of magnetism on the sun and predict how they will unfold days later at Earth. When a flare and a CME combine, the result is like a solar storm in full symphony. First comes the flare, a brilliant flash, a warning shot of radiation racing across the void at the speed of light. It arrives in just over 8 minutes, an immediate announcement that the sun has grown restless. Then, hours or even a day later, the CME follows, the heavy storm cloud crashing into Earth's magnetic field like a great drum being struck. The flare dazzles, the CME disrupts. Together they can overwhelm satellites, expose astronauts to radiation, and light up the skies with auroras so widespread they reach latitudes unaccustomed to such beauty. For most people on Earth, the result is wonder. For those who manage the power grids and satellites that bind our world together, the result is a reminder of how deeply connected we are to the moods of our star. In recent years, spacecraft have given us front-row seats to these cosmic performances. Observatories like SOHO and Stereo have captured CMEs in exquisite detail, watching from their vantage points as loops of plasma swell, break, and billow outward. In those images, we see vast arcs curling gracefully into space, wings of light scattering in all directions, structures so delicate yet so immense they seem to belong to another scale of reality. These pictures are not only beautiful, they are practical. They allow scientists to measure the speed and direction of CMEs, to build models that give Earth warning and time to prepare. Studying CMEs reveals something essential about the sun, its dual nature. It is both giver and taker, both nurturing and threatening. Its light sustains life, and yet its storms can disrupt the fragile lattice of technology on which modern society depends. In its chaos there is also order, the same magnetic fields that power the solar cycle, that sculpt the 11-year rhythm of sunspots, also give rise to these storms. The same physics that throws clouds of plasma across space operates not just here, but across the universe, in distant stars, in nebulae, even in the hearts of galaxies. The sun, in all its restlessness, is also a window into the cosmos itself. And Earth is not alone in feeling these tempests. Mars, with its thin atmosphere and weak magnetic field, is especially vulnerable. CMEs peel at its air, stripping it away piece by piece, leaving the planet barer than it once was. Venus, too, with no magnetic shield, feels the direct force of the solar wind. Even the giant planets cloaked in strong magnetic fields are stirred when CMEs wash past, their auroras glowing in ultraviolet light invisible to human eyes. For distant worlds orbiting less stable stars, the storms may be the deciding factor between a planet that can nurture life and one that remains barren forever. To picture a flare and a CME together is to see two expressions of the same magnetic drama. One is light, quick and brilliant, a shout of radiation. The other is matter, heavy and enduring, a tidal wave of plasma with weight and momentum. Alone, each is remarkable. Together, they form a reminder that our star is not a machine but a living presence, unpredictable, volatile, and alive. Their effects may disrupt, but they also gift us with wonders, auroras rippling like celestial curtains, curtains that remind us that even in chaos, beauty unfolds, curtains that whisper of our place in the story of a restless sun. When a solar flare erupts, it may feel like a distant spectacle, a firework on the surface of a star we cannot touch. But the energy released does not remain there. It rushes outward, reaching Earth in minutes, tugging at our magnetic field, stirring the invisible cocoon that surrounds and protects us. This is where the story turns closer to home, to the shield that guards our world, Earth's magnetosphere. Deep beneath our feet, in the molten currents of the outer core, Earth's magnetic field is born. It swells outward, surrounding the planet in a bubble, a cocoon invisible to the eye yet vast in size. On the side that faces the sun, this cocoon is compressed, pressed tight by the constant breath of the solar wind. On the far side, it stretches long and thin, trailing into space like a tail many times longer than Earth itself. This is the magnetosphere, a silent guardian, deflecting the charged particles that rush toward us. Without it, our atmosphere would have been stripped away long ago, leaving our planet as barren as Mars. When radiation from a solar flare arrives, it strikes first at the upper atmosphere. X-rays and ultraviolet light ionize atoms in the ionosphere, the fragile layer where gases become electrically charged. This sudden change disturbs radio signals, turning clarity into static, bending long-distance communication into noise. Pilots, navigators, and operators may find their instruments faltering for moments, as if the sun itself has briefly spoken through the air. But when a CME follows, the story deepens, and the drama becomes more layered. The great cloud of plasma does not simply pass by unnoticed. It slams into Earth's magnetic cocoon with the weight of 1 billion oceans compressing it, shaking it, twisting its invisible field lines into shapes that cannot be seen but can certainly be felt. In those moments, a vast energy is transferred into our skies. Invisible currents surge through space, and above the polar regions something wondrous begins. Charged particles spiral downward along magnetic pathways, as though they were travelers following ancient roads. They collide with atoms of oxygen and nitrogen in the thin air high above, and those collisions ignite light. Curtains of green, crimson, violet, and indigo unfurl across the heavens, shimmering and bending like fabric stirred by a hidden breeze. These are the auroras, the most enchanting signature of storms from the sun. To see them is to know that a storm from 150 million kilometers away has finally touched Earth. Entire night skies glow with shifting veils of color, vast enough to cover whole horizons. It is a dance of physics and beauty woven together, a ballet of particles and light that has inspired awe for as long as human eyes have gazed upward. Ancient stories call them celestial foxes, dancing spirits, messages from gods or ancestors. Modern science explains the collisions, the atoms, the photons, yet the mystery remains, for knowledge does not diminish wonder. In powerful storms, auroras creep far south, spilling into latitudes where skies are normally dark and plain. Imagine walking beneath a calm night sky and suddenly finding it alive, a canvas painted by an invisible hand, sweeping green arcs and violet flames flickering overhead. Surprise encounters like these remind people, often unexpectedly, that our planet is not isolated. We are connected, tethered by invisible threads to the moods of our star. Yet alongside this beauty lies a more practical, even sobering concern. The same magnetic surges that paint the heavens also travel downward. They flow invisibly into the ground, where power lines, pipelines, and long electrical grids act like enormous antennas, picking up these currents whether they wish to or not. Sometimes the results are minor, harmless fluctuations, but sometimes the currents overwhelm. In March of 1989, a geomagnetic storm unleashed by a CME swept across North America. In Quebec, transformers faltered. Within moments, the electrical grid collapsed, and millions of people found themselves plunged into darkness for 9 long hours. Below, the machines that lit their cities and powered their lives had gone silent. It was a reminder that space weather, for all its beauty, has teeth. High above Earth, satellites face their own trials. A storm heats the outer layers of the atmosphere, causing it to puff outward ever so slightly. That tiny expansion increases drag on satellites in low orbit, tugging on them, shifting their paths, sometimes shortening their lives. Navigation satellites, the quiet custodians of GPS, must push their signals through a disturbed ionosphere, and in storms, those signals bend and waver. Communication satellites too can suffer as particles charge their surfaces, leading to unexpected malfunctions. For astronauts, storms bring an even more personal concern. Aboard the International Space Station, they retreat into shielded compartments, reducing their exposure as radiation levels rise. Future explorers traveling to the Moon or Mars will have no such easy refuge. Beyond Earth's magnetic umbrella, storms become more dangerous, and preparing for them will be essential to human journeys into deep space. Even here on Earth, the effects ripple into the ordinary routines of life. High-frequency communication, so vital for aircraft flying over the poles, can suddenly fade into static as the ionosphere shudders. Pilots and airlines reroute flights, stretching their paths away from the polar regions to maintain communication and reduce radiation exposure for passengers. It is a small adjustment, but a telling one, proof that the sun's storms reach quietly into the fabric of human schedules, altering flight plans, shifting routines, reminding us of their unseen presence. And perhaps what makes these effects so challenging is their variability. A small flare may pass without notice, like a whisper barely heard. A powerful flare paired with a great CME, however, can ripple across continents, testing satellites, shaking power grids, and transforming skies with auroras no one expected. Unlike earthly weather, which rolls across landscapes in clouds and rain visible to the eye, space weather is more elusive. It arrives suddenly, sweeping across scales that defy imagination. To anticipate these storms, scientists rely on sentinels stationed in space. Spacecraft such as the Solar and Heliospheric Observatory, along with other vigilant companions, gaze constantly at the sun and the solar wind. They measure, they watch, they listen. Their alerts give Earth precious minutes, sometimes hours of warning, enough time to turn satellites, reroute flights, adjust grids, enough time, in other words, to prepare. And yet, despite the challenges, there is something deeply humbling about the reach of these storms. The sun sits 150 million kilometers away, yet its breath, its moods, its tempests ripple into our atmosphere, into our machines, into our very skies. It is a reminder of our planet's fragile position within the cosmic web, protected only by a thin atmosphere and a magnetic cocoon. Without those guardians, life itself would be impossible here. Solar storms would strip away our air, peel back our oceans, and leave Earth as barren as Mars. In the end, the interaction of solar flares and CMEs with Earth is a story of balance. The magnetosphere deflects and absorbs. The atmosphere glows and shields. Human ingenuity adapts and prepares. Most of the time, storms bring only auroras, soft and shimmering, drifting across polar skies like whispers of light. At rarer times, they ripple more deeply, testing the resilience of a civilization bound together by electricity and communication. There is a quiet poetry in this arrangement. A star, vast and ancient, breathes out storms of light and matter. A planet, small and fragile, answers with glowing skies and the occasional flicker in its machines. It is a dance, as old as the Earth itself, unfolding long before humans built telescopes or power grids, long before stories were written about foxes or spirits in the sky. To live beneath this relationship is to share in a cosmic drama, to know that our nights are painted not only by the faraway stars, but also by the living hand of the star that warms our days. When storms reach us, they do not always arrive with disruption or threat. Sometimes they come more gently, like a painter brushing soft strokes across the canvas of the night. These strokes are the auroras, veils of green and crimson, violet and indigo, rippling across thousands of kilometers of sky. They are the most visible and enchanting signs of the sun's tempests. They are reminders that even in the violence of cosmic storms, beauty descends quietly to Earth. The origin of this spectacle lies in the solar wind itself. Each flare, each CME, hurls charged particles outward. Earth's magnetic field catches them, bending them along invisible pathways that curve toward the poles. Guided downward, they fall into the upper atmosphere, between 100 and 300 kilometers above the ground. There, they collide with atoms of oxygen and nitrogen. The collisions excite the atoms, gifting them with energy they cannot hold, and when they release that energy again, they do so as light. It is the same principle that makes a neon sign glow in the night, except here, the sign is not a single tube but a sky, vast, luminous and alive. The colors depend on the atoms and the heights of their dancers. Oxygen struck at lower altitudes glows green, the most common and familiar of auroral hues. At higher altitudes, oxygen breathes red into the sky, a rarer shade, dramatic and almost surreal. Nitrogen, when struck, gives purples and blues, often forming the fringes and edges of the glowing curtains. Together, these colors weave into living tapestries, sometimes smooth, flowing like rivers of silk, sometimes jagged and restless, flickering like flames or lightning slowed to a crawl. For those who live under the auroral ovals, the rings encircling Earth's poles where the lights are most common, auroras are part of life's rhythm. In Alaska, in Scandinavia, in Canada, they appear often, turning long winter nights into natural theatres of colour. For others, they are rare gifts. Yet when storms are strong enough, the curtains spread far beyond their usual homes. History tells of auroras glowing as far south as the Caribbean, bewildering those who had never imagined the sky could behave in such a way. It is little wonder that auroras have inspired myth and story across the centuries. For those who lived under their glow, the lights were never ordinary. They seemed alive, purposeful, touched with meaning. To the Sami of the far north, they were spirits, a reminder to tread softly and to speak with reverence when the sky itself was moving. To the Inuit, they became a game in the heavens, spirits tossing a ball made from a walrus skull, laughter hidden in the flickers of light. In Norse mythology, the lights were thought to be the gleam of Valkyrie's armor, their shields flashing as they rode across the sky, guiding fallen warriors to the halls of the afterlife. In medieval Europe, when blood-red auroras flared unexpectedly, people whispered of war, of famine, of disasters yet to come. The skies themselves seemed to foretell strife. To others, the lights were blessings, celestial signs of power, a reminder that the world was larger than the land beneath their feet. Each culture gazed upward and wove its own story into the shimmering curtains. And even now, with science to describe the atoms and the particles, the magic remains. If anything, the knowledge deepens the wonder, to understand that every flicker, every shifting ribbon of light is the trace of a single charged particle, a traveler that began its journey in the blazing heart of the sun, crossed millions of kilometers of space, and finally gave itself up in a collision high above our heads, is to feel connected to the cosmos in a very intimate way. The aurora is not just a spectacle, it is a story unfolding in light. The auroral curtain is never still. It is not a painting fixed upon the canvas of the night, but a living, moving tapestry. Sheets of light ripple and fold, as though the sky were made of cloth stirred by a silent wind. Spirals twist into arcs, bursts flare then fade into softer glows. To watch an aurora is to watch the magnetosphere itself breathing, its invisible lines of force responding in real time to the storms arriving from the sun. No two displays are ever the same. Each one is unique, a fresh expression of the bond between our star and our planet. Beyond their beauty, auroras are also tools. To scientists, they are more than a light show. They are gauges glowing across the sky, offering clues about the strength of geomagnetic storms, about the flow of particles, about the structure of Earth's magnetic field. Instruments on the ground, satellites in orbit, together they watch and measure, translating the flickering lights into data. The aurora becomes both art and instrument, a glowing signature of the sun's tantrums written directly into our atmosphere. But there is another truth to these lights. They are not only a gift of beauty, they are also a sign, a very present signal that charged particles are flooding into the upper atmosphere. For the machines that we have come to depend on, that signal can mean trouble. Navigation systems may falter, communication may stutter, satellites may strain under electrical surges. To pilots flying polar routes, to operators guiding satellites, the aurora is not just a wonder, but a warning. For most of us on the ground, though, the disruption passes unnoticed. What remains is the spectacle, the silent, shifting radiance above. To witness a strong aurora is to feel both small and uplifted. To stand beneath a sky ablaze with colour is to realize that Earth is not apart from the cosmos, but deeply woven into it. The very air above your head is alive with energy that began 93 million miles away, transformed by invisible magnetic fields into light that brushes softly across the night. Perhaps the greatest gift of the aurora is its dual nature. It is born of storms that can challenge our preparations, threaten our networks, test our resilience, and yet to human eyes it arrives as beauty. What begins as turbulence in the tangled magnetic fields of the sun ends as curtains of colour dancing over frozen forests, icy seas, or quiet tundra. It is a transformation from chaos into calm, from violence into grace. In that transformation lies a reminder of the balance at the heart of the universe, that even from the most violent processes, astonishing beauty can emerge. To see the aurora is to see the invisible made visible. It is to watch the breath of a star woven gently into the sky above our heads. And sometimes, as history shows us, that breath grows into a storm of extraordinary power. On a late summer morning in the year 1859, an English astronomer named Richard Carrington stood at his telescope, sketching sunspots as he did on most days. The sun was restless, dotted with dark marks that hinted at turbulent fields beneath. As Carrington traced their patterns in careful detail, something extraordinary unfolded. A sudden flash of white light erupted across the face of the sun, so brilliant that it outshone the very sunspots he was recording. He blinked, startled, scarcely able to believe what he had just seen. In that instant, Carrington had become the first person in history to directly observe what we now call a solar flare. What followed etched his name into both astronomy and human memory. Within hours of Carrington's observation, Earth began to feel the storm. The initial blast of radiation stirred the upper atmosphere, but it was the coronal mass ejection that carried the true weight of the sun's fury. It raced across space faster than almost any storm before or since, billions of tons of plasma and magnetic fields hurtling outward, twisted and tangled by the turmoil of the star. When it reached Earth, the impact was unlike anything recorded in human history. The auroras that followed were astonishing. They stretched from the northern latitudes all the way into the tropics. In the Rocky Mountains, miners woke in the middle of the night, convinced it was dawn, and began preparing breakfast beneath skies glowing green and crimson. In the Caribbean, sailors gazed in disbelief as luminous curtains rippled across the warm night air. Across cities and villages, the skies turned into theatres of colour so bright that newspapers could be read at midnight. To some, the lights were terrifying omens. To others, they were simply beyond comprehension. But the storm's most dramatic effects were not in the heavens. They were in the wires that bound the 19th century together. Telegraphy, the cutting-edge technology of the age, stretched copper lines across continents, carrying messages at speeds unimaginable to earlier generations. And in those wires, the storm awoke a strange and unsettling power. Operators found their instruments sparking, their batteries overwhelmed by surges of natural electricity. Some were shocked as sparks leapt from their keys. Others, amazed, discovered that even with the batteries disconnected, their systems continued to function. Messages carried not by man-made power, but by the storm itself. One operator in Boston wrote of shocks so strong that sparks flew in every direction, as though the very air had been electrified. Telegraph offices caught fire, lines faltered and failed, communication networks strained under the weight of a storm that cared nothing for human invention. Yet in that chaos, a new truth revealed itself. The sun across its immense distance could reach into human technology and shape it, disrupt it, even animate it. The Carrington event, as it came to be known, remains the most powerful geomagnetic storm ever recorded. Its memory has grown heavier with time. In 1859, the most advanced technology was the telegraph. Simple copper lines stretched across continents, carrying dots and dashes that seemed miraculous to those who first heard them. Today, by contrast, our world is wrapped in an invisible net of signals and electricity. Satellites circle overhead, whispering timing codes that guide planes across oceans, synchronize financial networks, and steer ships through narrow channels. Vast electrical grids hum beneath our feet, tying cities, countries, even continents together in one delicate chain of current. Fiber cables cross the seas, binding continents with pulses of light. To imagine a storm of Carrington's magnitude striking this web is to glimpse the fragile thread on which modern civilization now hangs. If a true Carrington-scale storm arrived in our age, the challenge would dwarf anything faced by the telegraph operators with their sparking wires. Scientists and planners often use that event as a benchmark, asking with unease, what would it mean for us if such a storm came again? The answers are sobering. Modern power grids, with their vast interconnected networks, are particularly vulnerable to geomagnetically induced currents. A storm of that strength could overload transformers, damage substations, and trigger cascading blackouts that might last not hours or days, but months, even years. The machines that move electricity across continents are massive, intricate, and slow to replace. To lose many of them at once would be to dim entire regions of the Earth for a span of time difficult to imagine. Above our atmosphere, the vulnerabilities multiply. Satellites, the silent partners of modern life, could be scarred or destroyed by the storm. A single powerful CME can bathe Earth's orbit in high-energy radiation, charging spacecraft surfaces, frying delicate electronics, and stripping power from solar panels. Navigation systems might falter. Communication links could collapse. Entire constellations of satellites, carefully choreographed to orbit with precision, could be knocked silent. For airlines, ships and emergency services, the loss of GPS would be more than inconvenient. It would be disorienting, even dangerous. And for financial networks which rely on precise satellite timing, the disruption could ripple into markets, transactions and economies worldwide. It is not exaggeration to say that a Carrington-scale storm today would touch nearly every part of human life, from the lights that guide us at night, to the signals that link our voices, to the invisible currents that move money and information across the world. This is why the Carrington event has become not just a tale of the past, but a touchstone for modern science. It is both caution and lesson, a reminder of what our star is capable of, and a natural laboratory from which we can learn. Astronomers search not only in old observatories and journals, but also in the archives of nature itself, in the ice of Greenland, in the rings of ancient trees. These places carry subtle records of radioactive isotopes created when the sun erupts with extraordinary force. The evidence whispers of storms past, some perhaps even greater than Carrington's, storms whose traces remain long after their lights faded from the sky. From these studies, scientists believe such events occur not every century, but every few centuries, rare but not impossible, a roll of the cosmic dice that sooner or later will come again. And perhaps it nearly did. In July of the year 2012, our planet narrowly escaped what could have been one of the most disruptive natural events in modern history. On that day, the sun unleashed a colossal coronal mass ejection, a storm so powerful that researchers later compared it to the Carrington event itself. Billions of tons of plasma were thrown outward, carrying twisted magnetic fields and surging with energy. But this time, Earth was spared by the simplest of chances. The storm was not aimed at us. It roared through the very space where Earth had been just 1 week earlier. Had our planet been there, had the timing been just slightly different, the world might have awakened to a morning where satellites went silent, power grids shuddered and failed, and communications fell into darkness. Unlike in 1859, when sparks startled telegraph operators, the consequences in our century would have been vastly more profound. Our dependence on spaceborne systems makes us vulnerable in ways unimaginable to Carrington and his peers. Satellites carry our maps, our forecasts, our conversations, our transactions. They are guardians of navigation, of weather, of global timing. A direct hit from a storm as powerful as the one of 2012 could have disabled dozens, perhaps hundreds of satellites in orbit, leaving entire regions without the tools that quietly knit the world together. The threat extends beyond the heavens. On the ground, power grids that stretch across continents are susceptible to the invisible hands of geomagnetic storms. When currents surge through long wires, transformers strain and overheat. A single transformer can weigh hundreds of tons and take months to replace. In March of 1989, a geomagnetic storm, far weaker than Carrington's, caused the collapse of Quebec's electrical grid in less than 2 minutes, leaving millions in darkness for 9 hours. That was a moderate storm, and yet the disruption was profound. In a Carrington-scale event, the strain would be far greater. Blackouts might last weeks, even months. Hospitals would rely on dwindling generators. Water systems, transport, industry and communication all would falter under the weight of silence. And still the dangers would not stop at the ground. High-energy particles rushing into Earth's orbit can scar satellites, but they can also endanger astronauts. Within the protection of Earth's magnetosphere and atmosphere, we are largely shielded. But those in orbit, aboard the International Space Station, are more exposed, retreating into shielded modules when storms arrive. For future explorers heading to the Moon or Mars, the danger is greater still. Beyond Earth's magnetic cocoon, a Carrington-class storm could deliver lethal doses of radiation within hours. Space agencies monitor the sun relentlessly, ready to act, but the risk lingers like a shadow over every plan to journey deeper into space. The 2012 near miss was not our only brush with danger. Scientists reading the records of nature have discovered signs of even older storms, storms whose intensity may have surpassed Carrington's. In the year 775, and again around the year 993, tree rings and ice cores reveal sudden spikes in radioactive isotopes, silent markers of solar tempests that battered Earth more than 1,000 years ago. No written records survive to describe the skies of those years, but the natural evidence suggests storms far greater than anything modern humanity has yet witnessed. These findings remind us of a sobering truth. The sun, our life-giver, is also capable of tempests beyond our current experience, and though rare, such storms are part of its nature, not if, but when. To prepare, we have stationed sentinels in space. The Solar and Heliospheric Observatory, the Solar Dynamics Observatory, and the Parker Solar Probe, each watches, each listens. Satellites at the L1 Lagrange point, 1.5 million kilometers sunward, serve as early guardians, tasting the solar wind before it reaches Earth. When a CME is detected, models are run, trajectories are traced, and alerts ripple outward to power companies, to airlines, to satellite operators. Sometimes this warning grants hours, sometimes only minutes. But even a little time can make the difference between resilience and disaster. And yet, for all our progress, predicting solar storms remains an imperfect science. Unlike hurricanes, which swell slowly and trace their spirals across oceans, coronal mass ejections are creatures of sudden violence. They are born from tangled magnetic fields deep within the sun, erupting outward with little warning, vast storms of plasma hurled into space. Their speed can be measured, their size can be traced, but their magnetic orientation, the key to whether they will slide harmlessly past or slam into Earth's magnetic shield, remains elusive until they are almost upon us. Even with fleets of satellites and observatories, even with decades of accumulated data, the precise impact of a CME is something humanity still cannot know until the last moments. For all our sophistication, we remain in some measure at the mercy of our star. The possibility of another Carrington-level storm lingers, neither fantasy nor certainty, but a quiet, persistent question. It drifts in the background of science like a whisper in the dark, half warning, half promise, a reminder written not in books but in the sky itself, that the calm days and quiet nights we so easily take for granted are fragile. They are temporary. They are gifts lent to us beneath the watchful gaze of a star that is both protector and threat. It is not only a scientific concern, but a societal one. Engineers debate how to build transformers less vulnerable to geomagnetic surges. Policymakers weigh investments in more resilient satellites, systems able to weather the storm rather than fail in silence. And yet, progress is slow, caught between the urgency of preparation and the pull of competing priorities. The cost of protecting against the rarest storms is often set aside in favor of more immediate concerns. In the meantime, every strong solar storm that brushes against Earth becomes a rehearsal, a reminder that the sun does not always keep to its gentle rhythms. For most of us, the threat feels distant, almost unreal. Solar storms are overshadowed by the pressing concerns of daily weather, of politics, of economics, of ordinary life. Yet the near miss of 2012 remains a stark reminder of how easily our interconnected world could be shaken. Imagine waking one morning to find GPS silent, phones that no longer connect, banking networks frozen, flights grounded, the grid dark and silent across nations. In days, water pumps would falter, food distribution would slow, hospitals would struggle. The ripple effects would spread in widening circles, not because of malice, not because of war, but because of the temper of a star. It is not science fiction. It is a natural hazard, written into the restless heart of the sun and preserved in the history of our planet. And so each near miss serves a dual purpose. It warns us of what could be lost, but it also awakens awe at the delicate balance that allows civilization to thrive at all, perched beneath a star that nourishes and threatens in equal measure. Each flare that passes harmlessly, each CME that sails just wide of Earth, is both a relief and a reminder. A relief that this time our fragile systems endure. A reminder that one day the dice may fall differently. The Carrington event taught us that solar storms can reach across space to alter the course of human history. The storm of 2012 whispered that such a moment may come again. The question that lingers, quiet but insistent, is whether we will be ready. High above our heads, far beyond the weathered sky of clouds and jet streams, an entire fleet of sentinels keeps watch. They are the guardians of our modern age, spacecraft built to study, monitor, and anticipate the moods of the restless star. To most people, they are invisible, silent companions drifting in space, but their role is profound. For all the brilliance of our modern technology, from smartphones to satellites, our lives remain tethered to the sun's rhythms. We depend upon understanding its tempests. That is why NASA, the European Space Agency, and research groups across the globe have built a vigilant network, a watchtower of science and protection that never sleeps. The importance of these sentinels becomes clear when you consider how quickly the sun can change. A flare erupts in minutes, its light racing to Earth in under 10. A coronal mass ejection takes longer, a day or two perhaps, but once it is launched, the clock is ticking. For Earth, every hour matters. Power grids may need to shift their loads, rerouting current to protect transformers. Airlines may need to adjust routes away from polar skies where radiation surges strongest. Satellites must fold into protective modes, shielding delicate instruments. Astronauts may need to retreat into shelter. Without forewarning, a storm could blindside civilization. With even a small window of preparation, its impacts can be softened, its chaos managed. One of the oldest and most enduring guardians is the Solar and Heliospheric Observatory, SOHO. Launched in 1995, a joint effort of NASA and ESA, it has held its post for decades at the L1 Lagrange point, 1.5 million kilometers sunward of Earth. There it floats in perfect balance, keeping an unblinking eye upon the sun. SOHO peers into the solar interior, studies its surface, and watches the delicate outer atmosphere, the corona, where storms are born. But its most famous role is as a sentinel for CMEs. Again and again, SOHO has captured vast arcs of plasma bursting outward, expanding like rings across space. By tracing their size, their speed, and their direction, it gives humanity precious hours to prepare. If SOHO is the distant watchtower, the Solar Dynamics Observatory, SDO, is the close-up lens. Launched in 2010, it sees the sun in exquisite detail across many wavelengths. To look at SDO's images is to see the star alive with motion, loops of plasma twisting in arcs, sunspots seething with magnetic tension, flares erupting in flashes of brilliance. For scientists, these images unravel the mechanics of solar activity, the tangled ballet of magnetic fields, reconnections and eruptions. For the public, they are cosmic art, images so strange and beautiful, they hardly seem real, yet they are the daily life of the star that sustains us. And then there is Parker. The Parker Solar Probe, launched in 2018, is perhaps the boldest of all the guardians. Unlike SOHO and SDO, which observe from safe distances, Parker plunges into the storm itself. Protected by a heat shield, it flies closer to the sun than any craft before it, diving into the corona, skimming through regions of space where temperatures rise above 1,000 degrees Celsius. At its peak speed, over 430,000 miles per hour, it becomes the fastest human-made object in history, fast enough to cross the continent in seconds. Its mission is daring: to taste the plasma, to measure the magnetic fields, to seek the answers to mysteries unsolved for generations. Why is the corona hotter than the sun's surface? How are particles hurled outward with such astonishing force? Parker seeks these answers from within the furnace itself. Together, these spacecraft form a layered defense. SOHO, the sentinel afar, scanning for storms on the horizon. SDO, the close observer, watching the birth of flares in fine detail. Parker, the fearless diver, plunging into the storm to reveal its secrets. To them are added others, the twin Stero probes that once gave us three-dimensional views of solar eruptions. The Solar Orbiter, launched by ESA in 2020 to glimpse the sun's poles, and national missions like Japan's Hinode and India's Aditya Lel-1, each adding its vision to the watch. Even on Earth, great observatories like the Daniel K. Inouye Solar Telescope in Hawaii lend their eyes, recording the surface of the sun in detail never seen before. This vigilance is not just science, but survival. The data flows constantly into centers like NOAA's Space Weather Prediction Center and ESA's Space Weather Coordination Center, where models are run and warnings are issued. Much like terrestrial weather forecasts prepare us for hurricanes and floods, these alerts prepare us for tempests of another kind. Airlines adjust flights, power companies brace grids, satellite operators switch modes, and always, humanity leans just a little further into preparedness, hoping the warning will be enough. The global nature of this watch is worth pausing over. Though nations may compete on Earth, in the domain of the sun they often cooperate, for solar storms respect no borders. A flare unleashed in the corona does not care if its light falls upon Europe, Asia, Africa, or the Americas. It strikes all with equal force, and so, quietly, a network of collaboration endures as humanity stands together beneath the shared sky. Perhaps what makes these guardians most remarkable is not only their technical power, but what they represent. They are our acknowledgement of humility. They are a recognition that we cannot control the sun, but we can listen, we can watch, we can learn. Each spacecraft is like a lighthouse, casting its beam across the solar seas, warning us of storms before they arrive on our shores. In that balance lies both the challenge and the triumph of exploration. We are small in the face of the cosmos, and yet, in our smallness, we carry resilience. To stand against the storms of the sun is not to defeat them, but to endure them, to bend without breaking, to prepare with patience and foresight. Every flare that shakes our instruments, every CME that brushes past our planet, every particle storm recorded in the logs of a spacecraft, each is a lesson, a warning, yes, but also a gift of knowledge. The very act of confronting these forces transforms danger into discovery. For astronauts, the reality of radiation storms is more than a technical hazard. It becomes part of the psychology of living beyond Earth. Imagine drifting in the silent void, seeing the sun as a blazing coin outside the window, knowing that at any moment it may unleash a storm invisible to the eyes yet lethal to the body. The awareness sharpens everything. Every checklist, every sensor, every routine scan of solar weather reports. It demands trust. Trust in the engineers who built the shielding. Trust in the scientists who monitor the satellites. Trust in the crew who will retreat together to the storm shelter when the alarms sound. In this way, solar flares are not only tests of physics but of human solidarity. They remind explorers that survival is never individual, it is collective, bound together by preparation, cooperation, and the shared will to face what lies ahead. As humanity looks toward a future on the Moon and Mars, these challenges take on new dimensions. A base on the Moon may one day house dozens of people, perhaps entire crews rotating in and out, carrying out science, mining resources, building infrastructure. Within such a base, storm shelters will not be afterthoughts but central features. They may take the form of cavernous chambers carved into lava tubes, their ceilings thick with rock that blocks radiation, or they may be layered habitats, their walls packed with lunar regolith to shield against the sun's fury. Children born in such colonies might grow up with storm drills, the way children on Earth grow up with fire drills or earthquake practices, reminders that life beneath a restless star requires vigilance as much as wonder. Mars, with its thin atmosphere and absent magnetic field, demands even greater ingenuity. Settlers there will live in constant negotiation with radiation. Their homes may be buried beneath hillsides or domes, shielded with layers of ice. Their spacesuits might carry flexible shielding, woven with advanced materials designed to deflect or absorb particles. And above them, an entire network of satellites may orbit as guardians, scanning the sun, sending warnings across the void when a storm is detected. For those settlers, the cry of an alarm may one day mean the difference between routine survival and catastrophe. Yet in these very dangers lies a deeper connection. To protect ourselves from solar storms is to acknowledge the truth of our existence, that we live in the embrace of a star. It is easy to think of the sun as a fixture, a constant dawn and dusk, but the reality is more profound. It is alive, it is dynamic, it is endlessly active. Its light warms our oceans, its gravity holds our world in orbit, and its tempests remind us of its power. In learning to shield ourselves from its storms, we are not separating from it, but drawing closer, weaving our technology and our lives into its rhythms. Astronauts who face solar flares firsthand often speak of awe alongside fear. They know the risks, they feel the danger. And yet to see an aurora shimmering across the horizon from orbit, to watch the green and violet lights ripple along the magnetic field lines far below, is to witness beauty born from violence. The same storm that threatens satellites and power grids paints the skies with colors no artist could invent. This duality, danger and wonder, peril and beauty, is at the heart of the human relationship with the cosmos. The future will not eliminate these storms. The sun will not grow calm for our convenience. But humanity has never been defined by the absence of risk. We are defined by how we respond to it. Just as sailors once learned to read the winds and navigate seas that seemed endless, so too are we learning to read the language of the sun. We build our lighthouses not on shorelines but in orbit. We prepare not for waves of water but for tides of plasma. And in this preparation we claim our place as explorers, not victims. Without it, solar activity would seem random, a chaos of flares, storms and eruptions with no discernible order. But with the cycle revealed, we begin to see the hidden rhythm, the great breath of the star that sustains us. Each rise in sunspot numbers, each fall into quietude, is part of this cosmic metronome. It is as though the sun itself has a pulse, one measured not in seconds or minutes, but in decades. To follow it is to feel time on a stellar scale, to witness a story far older and slower than the fleeting pace of human life. The solar cycle is more than an astronomical curiosity. It is a reminder that we live within the moods of a star. When the sun grows active, the skies at high latitudes ignite with auroras, their curtains of green and red light rippling like cosmic silk across the heavens. Radio signals may falter, satellites may be buffeted by charged particles, and pilots flying near the poles may reroute to avoid the storm's interference. These are not distant events. They are lived experiences, evidence that the heartbeat of the sun reaches into the pulse of our daily lives. At solar maximum, the sun becomes restless. Sunspots bloom across its face, like dark seeds of magnetism, each one a knot of tension waiting to snap. Flares erupt with dazzling intensity, and CMEs unfurl into space like tsunamis of plasma. Earth, though shielded by its magnetic field, cannot remain untouched. Our auroras grow brighter, Our satellites strain under radiation, and our power grids must be guarded more carefully than ever. These years of heightened activity feel almost like a storm season of the cosmos, not guaranteed disaster, but a time of greater vigilance. Then comes the quiet, solar minimum. The surface of the sun smooths out, its blemishes fading, its tempests fewer and gentler. The auroras retreat to higher latitudes. Instruments that once rang with bursts of radiation now measure calm. Yet even here, in the quiet phase, the dynamo beneath the surface continues its unseen work. Magnetic fields are coiling, stretching, reversing. It is the pause before the next breath, the lull before the next crescendo. For scientists, the cycle is both a guide and a puzzle. Samuel Heinrich Schwab, who first revealed its rhythm in the 1840s, could scarcely have imagined the tools we now wield. Where he once sketched sunspots by hand, we now trace magnetic field lines with satellites, model their twisting with supercomputers, and map plasma flows deep inside the star with helioseismology, a kind of stellar ultrasound. Each discovery deepens our understanding, and yet mysteries remain. Why do some cycles roar with intensity, birthing flares that shake Earth's technology, while others whisper, subdued and gentle? Why did the Maunder minimum plunge the sun into decades of quiet, and could such an era come again? The answers matter, for the cycle shapes not only our skies, but the plans of explorers and engineers. A solar storm at the wrong moment could endanger astronauts en route to Mars. A peak of activity might threaten communication networks on Earth, while a lull might allow missions to venture farther with less risk. In this way, the rhythm of the sun is not just science, it is strategy, shaping when we dare to launch, how we protect ourselves, and what risks we are willing to take. Cycle 25, the one unfolding now, is our latest chapter in this ongoing story. Since 2019, the sun has been stirring, its face once again marked by sunspots, its flares growing bolder. Predictions suggested it might be weak, but early signs hint at surprising vigor. Each eruption, each aurora, each disruption to radio or GPS is both a challenge and a clue, a piece of the puzzle that helps refine our models. To watch this cycle unfold is to be reminded that we are students of a star, always learning, never fully in control. And yet, even in the uncertainty, there is beauty, a quiet kind of beauty that asks us to pause, to breathe, and to listen. To know that the sun has a heartbeat is to know that we too are part of its rhythm. Its great pulse drifts outward, carried by tides of magnetism, whispering across the silence of space. These invisible currents brush against our fragile world, stirring the air above the poles, bending our instruments, painting light across the skies, and in ways both subtle and profound, shaping our shared future. The solar cycle is a clock older than any calendar, older than language or song. It is a tempo that beats beneath the surface of time itself, a rhythm so vast that whole generations may pass before one cycle has fully played its tune. To study it is to slow down, to see beyond the flickering days of our own lives, and to sense the larger breathing of the cosmos. Each crest of activity, each retreat into calm, is like an inhale and exhale from the heart of the star, a steady breath that has never faltered in billions of years. To study the rhythm of the solar cycle is not merely to brace ourselves for cosmic storms, though such preparation is woven into its gentle necessity. It is to drift into the quiet wonder of patterns hidden within the sun's fiery heart, to find a soft calm in knowing that even chaos hums with an ancient order. It is to feel the vast, slow tide of time washing over us, whispering that what we call permanence is but a fleeting pause, a tender moment of stillness. Even the mightiest star, glowing with eternal radiance, sways through its own seasons, lulling us into dreams of cosmic harmony. This cycle, though it may seem unpredictable at times, offers a quiet reassurance like a lullaby sung by the universe. It invites us to see that storms rise and fade, that moments of calm carry their own sacred purpose, that the sun's blazing core is not wild without reason, but guided by rhythms too vast, too serene, for a single human life to fully grasp. In its gentle repetition we find something deeply comforting, a pattern to rest within, a reminder that we are cradled by a greater order, even when that order is veiled in soft mystery. Let your mind drift, carried by this rhythm, as if floating on a quiet sea under starlight. There is a poetry to this cycle, a slow, dreamy cadence that soothes the soul. The sun, which we imagine as a constant beacon, rising faithfully each morning and slipping below the horizon each evening, reveals a deeper truth when we let our gaze stretch beyond the fleeting span of days. Over decades, its steadfast glow dissolves into a delicate dance, a shifting weave of brightness and hush, of storms and stillness. It murmurs to us, in its sleepy way, that change is the truest constant, that beneath every calm surface there is a gentle motion, and beneath every steady light, a quiet pulse of movement. Close your eyes and feel this rhythm, like a heartbeat lulling you into rest. Just as Earth's seasons turn in their timeless waltz, guiding the bloom of flowers, the fall of snow, the stirring of new life, so too does the solar cycle weave its own seasons across the vastness of space. There are times when the skies above grow restless, shimmering with auroras that paint the night in soft glowing hues, and there are times when the heavens fall into a deep, undisturbed silence, the stars shining like quiet sentinels in the dark. To see the sun this way is to see it not as a fixed flame, but as something alive, breathing, dreaming. A companion whose gentle moods ripple through our lives, touching us with light and shadow as we drift through existence. In its essence, the solar cycle is both a scientific guide and a cosmic lullaby. It explains the dance of auroras, the sudden whispers of flares, the quiet appearance and fading of sunspots, the moments when the heavens feel alive with fire or slip into a serene emptiness. It is the rhythm by which the sun breathes, a slow, steady pulse that teaches us that even a star has its seasons, times of quiet energy and times of gentle storm. Let this thought cradle you, like a soft blanket of starlight, wrapping you in the comfort of the universe's eternal song. To watch this cycle unfold is like listening to the verses of a timeless melody, a song that began long before Earth took shape, a song that will hum softly long after our fleeting chapter fades. Its verses are slow, patient, and heavy with the weight of billions of years, yet each note finds its way to us, shimmering in the auroras above our poles, flickering in the quiet hum of our radio waves, glowing in the innocent wonder of a child gazing at the sun, unaware of the ancient rhythm that pulses beneath its light. Let your thoughts drift, carried by this melody, as if swaying in the arms of the cosmos itself. Our sun, though it may seem turbulent at times, is a gentle giant compared to the wild spirits of other stars scattered across the galaxy's vast expanse. What we call a great flare, rattling satellites, stirring our fragile networks, is but a soft flicker in the cosmic tapestry, a candle's glow against the roaring fires of the universe. Other stars unleash storms of unimaginable power, super flares that could reshape entire worlds. These are eruptions so vast, they rewrite the dreams of possibility, stripping away atmospheres, bathing planets in waves of radiant energy, transforming fertile worlds into silent, barren dreams. Rest in the thought that our sun is kinder, its storms a mere whisper compared to these cosmic tempests. Super flares first glimpsed in the early 21st century were revealed not by chance but by the patient gaze of telescopes like Kepler. These instruments, designed to seek distant worlds by catching the faint dimming of starlight, also captured moments of breathtaking brilliance, flares so immense they dwarfed anything our sun could dream. These outbursts, lasting hours or even days, were like cosmic sighs, reminders that not every star is as gentle as our own. Drift into this thought, letting it carry you like a soft breeze, marveling at the quiet balance of our star's light. For planets caught in the path of such a flare, the consequences are profound, like a dream dissolving into mist. Atmospheres, woven over eons, could vanish in a single fiery breath. Protective layers, those fragile veils that shield life from harm, might fade as if they had never been. Surfaces once kissed by rivers and winds could lie raw, bathed in tides of radiant energy. A world that once held the promise of life, where seeds might have drifted on gentle currents, could fall silent in the space of a single storm. Yet, as you rest in this thought, let it remind you of the delicate balance that cradles our own world, a balance that feels like a cosmic gift. And so we turn our hearts in quiet gratitude toward our sun's moderation. It may flare, yes, it may send ripples of its restless power across the sky, but it does so with a gentle restraint, a balance that feels like a lullaby. Its song is not a roar but a soft, steady rhythm, a heartbeat that has allowed life to take root, to grow, to dream beneath its glow. Our sun is a star that challenges but also shelters, that warns but also warms. In the vast lottery of the cosmos, this balance is a rare and precious gift, a melody that soothes us into rest. When astronomers lift their sleepy eyes to the stars, they see a gallery of stellar souls. Some stars glow with a quiet, unchanging light, as if content to simply be. Others burn with restless fire, their tantrums shaking the worlds around them. Our sun rests in a gentle middle, lively enough to remind us of its warmth, yet mercifully restrained compared to its wilder kin. It is this temperance, this soft equilibrium, that has given Earth the chance to become a cradle of life, a place where dreams can take root under a star's watchful glow. Let this thought lull you, like the gentle rocking of a cradle under starlight. The study of flares beyond our sun does more than unravel the secrets of magnetic storms. It reframes our place in the cosmos, whispering that life is not only born of oceans and time, but shaped by the temperament of the star that holds it close. For every world that rests in a habitable zone, kissed by just the right amount of light, there are others where flares rage too fiercely, where atmospheres cannot endure, where the dream of life fades into silence. Yet as you drift into this thought, let it carry you toward peace, knowing that our sun sings a gentler song, one that has allowed us to dream, to wonder, to rest beneath its light. The next time you hear of a solar flare rattling satellites, or of auroras painting the skies above polar nights, pause for a moment. Consider this on countless other worlds around countless other suns. Such storms are not rare disturbances. They are constant realities, woven into the daily rhythm of those planets. Imagine skies that flash with violence every few days, worlds where storms never truly end, and where life, if it arises at all, must hide beneath rock or ice to escape. For those places, the dream of life reaching the surface may forever remain out of reach, and in that contrast, in that quiet knowledge, there is gratitude. Gratitude that in the cosmic lottery of stars we were given one whose storms, though powerful, are merciful. The sun, as the giver of light and warmth, has always been bound to human imagination, woven into the stories of abundance and hunger, of summer and winter. Ancient cultures looked skyward and believed that a bright, generous sun promised harvests and fertility, while a hidden or weakened sun foretold famine and loss. Even then, before the language of science, people knew instinctively that the moods of the sun mattered. In our modern age, as we study flares and the restless churn of its magnetic fields, the same question lingers. Does the sun's activity truly shape the climate of our world? The answer, like so many in science, is both yes and no. Yes, the sun's variability plays a role. But no, it is not the sole author of Earth's changing climate. Its influence is real, but subtle, like a quiet background note in a symphony dominated by louder instruments. To begin, it helps to separate weather from climate. Weather is the passing moment, the storm that blows through, the sunlight that breaks the clouds, the snow that falls across a valley. Climate is slower, deeper, the long memory of all those weathers combined. Solar flares and their great companions, coronal mass ejections, shape what we call space weather dramatically. They rattle satellites, bend magnetic fields and stir the polar skies, but their effects are fleeting. A single flare, no matter how brilliant, does not shift the seasons, does not warm or cool the planet in lasting ways. For climate, we must look elsewhere, to the long and patient patterns of solar activity. Here, the story unfolds across decades and centuries, tied to the 11-year rhythm of sunspots. When sunspots are many, solar activity rises. When they vanish, the sun grows quieter. The difference in total energy is small, barely 0.1%, yet even such a slight change can ripple through Earth's delicate balance. History gives us clues. During the Maunder minimum of the 17th century, sunspots nearly disappeared for decades. At the same time, parts of Earth slipped into colder winters, rivers in Europe froze, glaciers advanced. This period became known as the Little Ice Age. The connection was not simple. Volcanic eruptions, ocean currents and other forces played their part, but the sun's lull likely helped tip the scales toward cold. This example reveals the truth. Solar variability matters, but it is never alone. It interacts with the whole Earth system, sometimes amplifying, sometimes softening, its effects woven into a larger tangled fabric of causes. Modern myths, however, often exaggerate its role. Some claim that our current warming is driven primarily by the sun, but the evidence tells a different story. Satellites measuring solar output over the past 4 decades show no rising trend that could explain Earth's sharp warming. If anything, the sun has dimmed slightly in that time. The heat we see today matches far more closely with the rising tide of greenhouse gases from human activity. The consensus is clear. The sun influences climate, but it is not the driving force of today's warming. Still, this does not mean the sun is irrelevant. Far from it. Variations in ultraviolet radiation, for example, can alter the chemistry of the stratosphere, shifting ozone levels and bending the paths of winds. These ripples can change rainfall, alter jet streams, and shape winters across continents. Some studies suggest that solar cycles may subtly influence patterns like the North Atlantic Oscillation, which governs Europe's winters. Small, yes, but real and worth listening to. There is also the question of cosmic rays. These high-energy particles sweep in from beyond the solar system, and the sun's winds, waxing and waning with its activity, shield us from them. When solar activity is high, fewer cosmic rays reach Earth's skies. When low, more arrive. Some researchers believe this might affect clouds, seeding droplets and shifting how much sunlight Earth reflects. The evidence is debated, the effects uncertain. If real, it is a subtle hand, not a dominant one. And yet, the deeper lesson is not in the size of the sun's influence, but in its constant presence. The sun is no rigid lamp fixed in eternity, no unchanging bulb glowing with mechanical precision. It is a living star, restless in its breath, evolving slowly but inexorably through the ages. Over billions of years, its gradual brightening has written itself into the history of our world, a hand that has turned the pages of Earth's story. In its youth, the sun shone more faintly, casting a gentler light across the infant Earth. By rights, the planet should have been an icebound sphere, oceans frozen hard, continents locked in frost. And yet, the atmosphere, thicker then, laced with potent greenhouse gases, held in the warmth like a blanket pulled tight, keeping the waters liquid, keeping the cradle of life open. Out of that balance life began, tiny and tentative, swaying with the tides of a dimmer but patient star. Far ahead, in the distant ages to come, the tale bends in another direction. Slowly, quietly, almost imperceptibly, the sun's furnace will burn hotter, its light more insistent. Oceans will simmer and rise into vapor, clouds will thicken and swirl, until at last the seas themselves vanish into space. Earth will drift beyond the habitable zone, a place it has called home for billions of years. The forests, the rivers, the pulse of seasons, all will bow to the inevitability of a brightening star. The sun has always been, and will always remain, a player in the climate of our planet. It is not a backdrop, but a character, shaping destiny not with sudden leaps, but with the patience of deep time. On the scales of days and nights, we feel its moods in bursts of flares and storms, brief dramas of light and magnetism. On the scales of years we mark its cycles, a steady heartbeat rising and falling with sunspots and auroras. On the scales of centuries, we trace its lulls and its peaks, its whispers of influence on frost and harvests. And on the scales of eons, we are drawn into its destiny, the long arc of its slow transformation. As we lie beneath its glow, warmed by its fire, yet soothed by its constancy, we are reminded that we live not beneath a machine but beneath a star, breathing, pulsing, changing, an immense companion that carries us through time. Our story is bound as softly and inexorably as a dream tethered to sleep, to the story of the sun itself. It is the ultimate arbiter of climate, the quiet stage upon which all earthly drama unfolds, and yet, on human timescales, its variations are whispers, gentle nudges compared to the loud shouts of greenhouse gases, volcanic eruptions, or the restless dance of oceans. The story of solar flares and climate, then, is one of proportion and patience. Flares themselves are dazzling, but momentary. They can disrupt technology, black out radios, scatter satellites, paint the skies with ghostly auroras, or drive astronauts into storm shelters. Yet they do not steer the climate's long road. They are sparks on the surface of a bonfire that burns on, steady and ancient. Longer solar cycles, with their faint variations in energy, leave a more enduring mark. They nudge patterns across decades or centuries, etching subtle textures into the climate record. From time to time, extended lulls like the Maunder minimum have coincided with colder eras, winters more severe, glaciers advancing, rivers stiffened into ice. But when we ask about the rapid warming of the present decades, the sun is not the leading character. The lesson is quiet, but profound. The sun, immense and powerful, sets the stage for life on Earth. Its energy breathes through winds, rains, and the turning of seasons. And yet, within that stage, the fine details are shaped by many players, by gases rising invisibly from smokestacks, by currents in oceans that drift unseen beneath the surface, by volcanic eruptions that veil the sky. The myths that place all the responsibility on the sun are comforting in their simplicity, but they overlook the intricate dance of forces. The truth is more wondrous. Our climate is not the work of a single master, but the product of a symphony, a weaving together of stellar rhythms, planetary feedbacks, and human choices. To think of solar activity in this context brings perspective, and with it, humility. The sun can throw storms that dazzle. It can stir auroras that set the skies alight. It can disrupt technologies we take for granted, but its fingerprints on climate are gentle and faint. It reminds us that we are bound to its rhythms. Yes, but not helpless passengers. We have agency. Our choices, small in cosmic terms, but vast in earthly consequence, can tip the climate far more sharply than the cycles of the star that sustains us. In the end, the connection between solar flares and climate is not one of direct control, but of quiet conversation. The sun breathes in cycles, and Earth answers with shifts and adjustments, weaving those rhythms into the greater tapestry of climate history. Understanding this relationship enriches our view of both star and planet. It shows us that science, when it listens patiently, reveals truths that are subtler, but also more enduring than the myths. Picture, then, an ordinary morning. You wake to the glow of a digital alarm clock, a silent gift of electricity. You check your phone, a device tied to satellites that orbit above, their signals dancing invisibly across the sky. You glance at the news while the coffee brews, unaware that power grids hum across continents, that time itself is kept precise by atomic clocks linked to satellites. All of this depends on the sun behaving, on its storms staying modest, on its flares remaining within bounds. Now imagine, quietly, slowly, that in the middle of such a day, the sun releases something far greater than usual, a flare of extraordinary power, a burst beyond imagination. Radiation floods the upper atmosphere in minutes. Hours later, a wave of plasma, vast and heavy, rushes across space and collides with Earth's magnetic shield. Lights flicker, then fail. Satellites stumble, power grids groan. The world, so modern and so dependent on invisible flows of electricity, suddenly feels its fragility. Astronomers call such an event a megaflare. It has not yet come from our star in recorded history, but we know it is possible. Other stars like ours, watched by telescopes such as Kepler, have flared with superstorms outbursts hundreds of times greater than the most powerful solar storms we have endured. Should the sun one day release such a breath, the consequences for civilization would be immense. At first, the disruptions might feel subtle, like faint tremors moving invisibly through the quiet networks that cradle our lives. A text delayed, a faint flicker on a screen, a momentary pause in the hum of communication, easy to overlook, easy to dismiss. But as hours stretch into days and days into weeks, the scale of the storm would emerge, slow and relentless. Satellites silenced one after another, communication fraying into static, navigation fading into guesswork, power grids trembling beneath currents they were never built to endure. The world would become quieter, slower, dimmer. Nights would deepen into velvet black, stars revealed with a brilliance forgotten by city dwellers, while above, auroras draped the heavens in flowing curtains of green and violet, ghostly veils whispering across the sky. It would not be the end of the world in flames, no cataclysm of falling cities, no shattering of continents. Instead, it would be a soft unraveling, a reminder of how delicate our woven threads of technology are, how much our days depend on the steady patience of a single star. Humanity would bend, but not break. It would adapt as it always has, learning to endure the quiet, and yet the memory would linger like an echo, an unspoken humility beneath the sleeping glow of the sun. The machines we trust, circuits orbiting above, wires humming beneath our feet are so constant we no longer notice them, but the disruption would be measured in silence, in disconnection, in the strange stillness of stalled systems. We would be forced to remember how deeply our lives are entangled with the rhythms of a star we cannot command. And yet, there would be resilience. Engineers would rebuild grids, new satellites would rise into orbit, communication would return. The challenge would not be permanent collapse, but the long, slow adaptation to weeks or months of disconnection. Communities might find themselves turning inward, rediscovering older rhythms of patience, leaning more on local trust than on distant signals. Families might gather by candlelight, neighbours might speak more often face to face, and towns might find themselves relearning a pace of life that moves slower, quieter. The experience would unsettle, perhaps frighten, but it would not be an ending. Humanity has endured storms of every kind, winds, quakes, wars, and winters, and it would endure again. Still, the lesson would be carved gently but deeply. Our sun, though it gives life and warmth, is not always kind. The same furnace that fuels green leaves and golden fields is also capable of storms vast enough to rattle our world. Most of the time, these flares are small inconveniences, curiosities that ripple into auroras. But once in a great while, the star may remind us that it is not merely a calm beacon, but a restless being capable of immense energy. To contemplate such a mega flare is unsettling, but also strangely inspiring. It shows how fragile our systems are, but also how extraordinary our achievements have been. How remarkable it is that we built a world so interconnected that even the moods of a star, 93 million miles away, can ripple through every breath of daily life. It invites not fear, but respect. Respect for the forces that shaped us, for the cosmic stage on which our fragile dramas unfold. And it leaves us with a lingering question. If such a storm came and silenced our machines, what would we learn in the quiet that followed? There is poetry in remembering that the sun, which rises each morning with dependable grace, is also capable of sudden fireworks. To us, it seems gentle, patient, a soft golden glow across fields and seas. But in truth, its surface seethes alive with motion, its magnetic fields coiling and snapping, its plasma dancing with fire. Solar flares are its punctuation marks, sharp bursts in a sentence of light. Through telescopes, the flares reveal their dreamlike artistry. Great arcs of plasma rise and loop, tracing invisible magnetic paths, glowing in ultraviolet light, like strokes of fire on a canvas of darkness. Loops taller than Earth swell and collapse in minutes. In X-ray visions, the sun becomes a storm-filled tapestry, knots of brightness blooming and fading, like sparks in a forge. The calm golden circle we glimpse by day hides a cauldron of fire and motion, an ocean of plasma stirred by magnetic tempests. And in these storms lies a paradox, fragility within enormity. A solar flare cannot burn the earth, cannot scorch away our seas or strip our skies, yet its radiation racing across the void in minutes can rattle our satellites and hum within our wires. Its reach is long, even gentle by cosmic measure, and still enough to brush against our fragile systems. Flares remind us of our protections, the magnetic shield wrapping Earth, the thick blanket of atmosphere above. Without them, life would face the star's full temper, naked to its fury. Mars, once warmer and wetter, lost its shield and much of its air. Exoplanets circling fiercer stars may never hold life at all, their chances undone by constant tempests. By contrast, Earth seems fragile, yet also profoundly fortunate, sheltered in just the right ways. Flares are both threat and gift. They disrupt, but they also paint the sky with auroras, veils of light that ripple like dancers born of chaos. Curtains of green, rivers of red, shimmering crowns of violet. To see them is to glimpse a language written in light, the breath of a star translated into beauty across our sky. This duality, danger and wonder intertwined, is at the heart of what makes solar flares so compelling. They are immense, dwarfing human experience, releasing energy equal to billions of nuclear bombs, and yet, in cosmic terms, they are but flickers on a star 1,000,000 times larger than our planet. Their power humbles, but also reminds us that we exist in a delicate balance, fragile beings on a small world, shaped and shielded by forces vast beyond comprehension. To reflect on solar flares is to reflect on scale. They are ancient, older than our species, older than our oceans, older than the very rocks beneath us. They raged in the early skies of Earth, perhaps shaping the chemistry that seeded life. Their cycles have pulsed through the ages, a drumbeat that the cosmos has always kept. Now, with instruments orbiting above the Earth, peering across the invisible spectrum of light, We watch the sun in ways that past generations could never have imagined. We see it not just as a golden circle in the sky, but as a restless star glowing across radio waves, ultraviolet flashes, and X-ray storms. Through these tools we measure its light, its particles, its rhythms, the heartbeat of a star expressed in flickers and flares. In watching, we come to admire not only the beauty, but also the volatility. Each flare is a reminder that the calm surface hides a deeper turbulence, and so we prepare, quietly, patiently, building systems that can withstand disruption, while never forgetting that awe and caution must walk hand in hand. In that balance between wonder and worry, between fear and fascination, lies a humility the universe gently asks of us. The sun does not flare to please us. It does not bend to the schedules of satellites or the demands of our machines. It flares because it must, because it is alive in its own way, driven by physics deeper than any human wish. It is restless, indifferent, yet profoundly beautiful. All we can do is observe, learn, adapt, and in the act of watching, we uncover not just data, but poetry. For to live beneath a star is to dwell within the embrace of both fire and grace. Here, in this strange intersection, science and poetry converge. The equations of plasma and magnetism unfold like verses, and the arcs of flame written across the corona become as awe-inspiring as any myth once told beneath starlit skies. To lie under the night sky, unaware of the flares erupting just beyond our sight, is to live both sheltered and ignorant, wrapped in a cocoon of protection we scarcely notice. But to open our eyes with telescopes, to watch the sun's hidden drama unfold in ultraviolet brilliance, is to awaken to the realization that even the most familiar star is a restless storyteller. In reflecting upon these outbursts, we confront the fragility of our existence. Protected by the thin layers of atmosphere and shielded by the invisible embrace of Earth's magnetic field, we are held safe from forces vast enough to erase us. And yet, those same forces give rise to beauty, to auroras shimmering across polar skies, to ribbons of light that remind us of our connection to the cosmos. The poetic fireworks of solar flares are not meant to frighten us, but to remind us beauty and danger are not opposites. They are companions. Fragility does not mean weakness. It is the condition of life itself, and that condition, paradoxical as it is, makes each moment beneath the sun infinitely precious. The paradox runs deep. A storm in the corona can darken the skies of technology, silencing machines, and yet that same storm can paint the heavens in shimmering veils of color, as if the universe wanted to balance disruption with wonder. The sun is not silent. It speaks, though not in words. Its language is radiation, rhythm, and light, patterns that unfold across centuries. Each flare is not a meaningless tempest, but a syllable in the star's great narrative. To study them is to listen, to attune ourselves to a voice written in fire. At its heart, the sun is powered by nuclear fusion, a furnace of unimaginable heat and pressure where hydrogen is steadily turned into helium. Yet the flares we see are not direct expressions of fusion, but rather the surface signatures of magnetism, born from the restless churn of plasma in its outer layers. Just as a heartbeat reflects the vitality of a body, the rhythm of flares reflects the pulse of the sun's magnetic field. They are not random outbursts. They are signals, glimpses into deeper processes hidden within the star. The story begins with the solar dynamo, the great engine that drives magnetism. Inside the sun, convective currents rise and fall like vast oceans of boiling water, carrying heat outward. The star also rotates differentially. Its equator spins faster than its poles. These motions twist and stretch magnetic fields, tangling them into knots of invisible tension. When the knots snap, energy is released in sudden brilliance. Each flare is a punctuation mark in this endless process. The sun writes its sentences in arcs of fire, and flares are its exclamation points. By observing these events, scientists piece together not only the immediate behavior of the sun, but also the broader story of stars. Our sun is middle-aged, about 4.5 billion years into a journey that may last 10 billion in total. Its flares, though impressive to us, are modest compared to the storms of younger, faster-spinning stars. Observations reveal that such youthful suns unleash superflares, eruptions so vast they make even our strongest events seem tame. Over time, as stars slow and settle, their tempers cool, their flares soften. Thus, the activity of flares becomes a clock, a measure of stellar aging. Our sun also breathes in cycles. Roughly every 11 years, its magnetic poles flip, and the number of sunspots swells and recedes. During solar maximum, the surface blossoms with dark spots and flares erupt with greater frequency. During minimum, the face of the sun smooths, its storms quieter. This rhythm is not trivial. It is a heartbeat that has echoed through human history, quietly marking the pulse of a star that predates us by billions of years. By following this cycle, scientists monitor the health of the sun's magnetic field, watching for signs of stronger or weaker activity that could shape Earth's future. Different wavelengths of light peel back layers of the sun's atmosphere, revealing its anatomy. A flare glowing in ultraviolet reveals the heated chromosphere. One bursting in X-rays maps energetic collisions in the corona. By weaving together these strands, astronomers create a portrait of energy as it moves upward through a star's skin. The sun, in essence, writes its autobiography in shifting light, and humanity is slowly learning to read its script. Beyond our own star, the story becomes richer still. Red dwarfs, the galaxy's most abundant stars, flare with astonishing regularity. Their fields are tangled, their storms frequent, their tempests fierce. To live near one is to endure a constant barrage of radiation, a challenge for life, though perhaps not an impossibility. Larger stars nearing their twilight flare less often, yet their magnetic breath still sculpts the shapes of their outer layers. By comparing these different lives, scientists weave a larger epic, stellar evolution written in bursts of fire. And yet, to think of flares as only data points is to miss their other meaning. They are luminous, fleeting, alive with motion. They are like sudden sparks of inspiration, like lightning flashes of creation itself. They remind us that stability is never absolute, that beneath the appearance of calm lies a restless heart. To study flares is to learn about plasma, about magnetism, about cycles of energy, but to reflect on them is to learn about impermanence, fragility, and beauty. They are both physics and poetry, science and philosophy. They are not just about the survival of machines or the protection of satellites, but about understanding our place in the cosmos. And yet, their lessons extend outward, beyond science, beyond Earth, into the great question of life itself. A planet orbiting a storm-prone star may be stripped of its air, its oceans boiled away by radiation, its surface left barren and silent. Another world circling a gentler star may enjoy eons of relative peace, its skies stable enough for rivers, forests, and creatures to bloom. In this way, solar flares are not just eruptions of plasma, they are sculptors of destiny, carving invisible boundaries that decide where life may flourish and where it is forever denied. Habitability itself is written in the handwriting of stars, their tempers as important as their warmth. To listen to the stories told in light and fire is to understand not only the sun but ourselves. We are fragile, yes, and our survival rests on delicate shields of atmosphere and magnetism. But we are also extraordinary, for we have learned to watch a star, to interpret its language, to hear its restless voice and turn it into knowledge, knowledge into wonder, wonder into humility. This capacity to transform cosmic violence into meaning may be one of the rarest traits in the universe, And so we see how precious our circumstances truly are, for the sun's role as a storyteller is not confined to distant abstract galaxies. It is written into the pages of our own history. The Carrington event of 1859, with its blazing auroras that stretched as far south as the tropics, its telegraph wires sparking with phantom fire, was one such chapter. Humanity, still new to the age of electricity, caught a glimpse of the star's true ferocity. More recently, the near miss of 2012, when a storm of staggering power passed harmlessly by Earth's orbit, reminds us that the story is ongoing. We are not merely bystanders, we are participants in the unfolding narrative of sun and civilization. Each flare, whether mild or monumental, is another verse in that story of connection. They remind us that the relationship between humanity and its star is active, evolving, in the centuries to come. As humanity ventures farther outward, flares will continue to shape the tale. They will dictate the thickness of spacecraft shielding, the design of habitats on the Moon or Mars, the timing of journeys through interplanetary space. Astronauts and settlers will learn, as we have, that even as they travel far from Earth, they remain tethered to the moods of the sun. The storyteller still speaks, and the challenge for explorers will not be to ignore its voice, but to keep listening. What makes this story even more remarkable is that it is told in silence. Solar flares do not roar through space with sound. In the vacuum, there are no ears to hear, no atmosphere to carry a voice. And yet they speak through pulses of light, through magnetic fields that ripple across 93 million miles, through storms that whisper against the shields of our world. It is a language not of words but of patterns, rhythms, signals written in fire. By learning to interpret these, we move closer to something profound. We are learning the grammar of stars. In the end, to see a solar flare is to glimpse the sun's inner self revealed for a moment, like a thought suddenly spoken aloud. Each flare is a word, each solar cycle is a paragraph, each age of stellar activity is a chapter in a story billions of years long. And we, brief inhabitants of a small blue planet, have the privilege of listening. We turn the sun's fiery language into science, its storms into knowledge, its light into meaning. The sun is not only our star, it is also our storyteller, narrating the tale of stellar life in a voice written in light. And yet, in our daily lives, the sun seems so steady, so familiar, that we often forget its restless nature. It rises without fail, marking mornings and evenings, the rhythm of days and seasons. To us, it is patient, dependable, almost calm. But look closer, and that illusion dissolves. Its surface is alive with storms. Boiling granules the size of continents rise and fade in minutes. Plasma loops taller than Earth leap skyward and collapse in arcs of fire. Beneath the surface, invisible magnetic fields twist and knot, storing tension until they snap, releasing sudden brilliance into the void. The sun does not sleep, it churns ceaselessly. The stillness we see is only an illusion of distance. And yet, it is this very restlessness that sustains us. The same light that erupts from its surface fuels photosynthesis, feeding plants, weaving the base of ecosystems. Its warmth keeps water flowing on our world, oceans liquid, climates habitable. Even its wind, the stream of particles blowing constantly outward, acts as a shield, pushing back the harsh rain of cosmic rays from interstellar space. In this way, the sun is both guardian and threat, both giver and taker, a paradox at the center of life. But that paradox is delicate. The same processes that warm us can also wound us. A flare that looks small against the sun's vast face can ripple across Earth, scrambling radio signals, disrupting navigation. A coronal mass ejection, hurling billions of tons of plasma outward, can rattle Earth's magnetic shield so violently that power grids falter, satellites fail, Astronauts retreat into shelters. The sun does not intend to threaten us. It simply is what it is. A star, vast, indifferent, bound to physics alone. Yet its indifference does not make it any less significant. Its storms touch our lives in ways profound and subtle alike. This dual nature, protector and threat, is what makes the sun such a compelling presence. Without its steady energy, Earth would be an icy rock, lifeless and still. With too much of its fury, Earth might be stripped bare like Mars, a desert under endless skies. We live in a narrow middle ground, a miraculous balance where the sun's generosity outweighs its violence, where its storms challenge but do not annihilate. To exist in that balance is to recognize both fragility and fortune. And here lies another paradox: to call the sun patient. It seems strange, when its surface is so violent, its flares so dramatic, but patience is a matter of perspective. On human timescales, the sun feels timeless. It has shone for billions of years, and will for billions more. Its cycles repeat with clock-like regularity. Its storms, however violent to us, are mere sparks in its history. On the scale of a star, even a mighty flare is only a flicker. And yet, on smaller scales, it never rests. Its equator spins faster than its poles. Its magnetic field flips every 11 years, a quiet but profound inversion. Streams of plasma flow ceaselessly, invisible to us, shaping space itself. Even in moments of calm, the sun is busy eddies and currents of plasma shifting beneath the surface, subtle pulses of energy gathering, waiting. To live beneath such a star is to inhabit a relationship that is both intimate and immense. Its light touches every blade of grass, every drop of water, every breath we take. Civilizations have risen and fallen under its gaze. Crops have flourished or withered depending on its moods. Ancient peoples named it God, guardian, or flame. And though it remains indifferent to our stories, it has been central to them all. Science gives us new ways of listening to this ancient storyteller. Telescopes reveal arcs of fire invisible to human eyes. Spacecraft dive into its wind, tasting its plasma, sampling its fields. We have learned that flares are not random, but signatures of deep processes in a magnetic heart. We know that its cycles are not chance, but the patterns of a restless dynamo. And still, the more we learn, the more mysteries arise. Solar flares capture this paradox perfectly. They are destructive, but also generative. They can disable satellites, yet create auroras more beautiful than any cathedral ceiling. They can threaten astronauts, yet teach us the physics of stars light years away. They last minutes, yet ripple across space for days, even weeks. They are tiny flickers compared to the sun itself, yet vast compared to us. And so, in the end, what lingers is not fear, but wonder. To live beneath such a star is to dwell in constant reminder of the universe's grandeur. Its storms humble us, its light sustains us, its paradox defines us. We are children of a star that is both patient and wild, calm and violent, nurturing and indifferent. To reflect on solar flares is to reflect on this truth. We are fragile, yet fortunate, brief, yet bound to something eternal. The sun gives us more than energy. It gives us perspective. Its storms remind us of invisible shields that guard our world, magnetism we cannot touch, fields we cannot see, protective veils that make life possible. Its light is a daily gift, warmth spilling across forests and fields, seas and cities, carrying silent nourishment to every corner of the earth. And its fireworks, the flares and auroras, remind us that even the most familiar presence in our sky is full of secrets, power, and beauty beyond measure. The sun never sleeps, and neither does its story. It is a tale written in fire and silence, an epic composed not in words but in plasma and magnetism. We are small, brief and fragile, yet we are privileged to witness it. Each flare, each aurora, each sunrise is a sentence in that story, a story that began billions of years ago, and one that will continue long after our brief age has passed. To look toward the sun is to see not just a source of light, but a companion, a patient yet restless neighbor, calm and explosive, protector and threat, a star whose eternal wakefulness makes our fleeting lives possible. The journey through the world of solar flares is in many ways a journey through the paradoxical nature of the star itself. To the casual eye, the sun appears steady, eternal, unchanging. Day after day, it rises, marking the rhythms of time. Civilizations have built calendars, rituals, and worldviews around its constancy, and yet beneath this comforting illusion lies a restless heart. The sun is alive with motion. Its magnetic fields twist, coil, and snap. Its plasma roils like boiling oceans of fire. Its energy escapes in sudden bursts, brilliant flares that flash across space in an instant. These flares are the most vivid expressions of its restlessness, sudden fireworks painted on the canvas of a star. Scientifically, solar flares remain puzzles. They arise from magnetic reconnection, a process where tangled magnetic field lines suddenly break and reform into new shapes, unleashing energy on scales that dwarf anything humanity has ever created. This process is both violent and elegant, chaotic and orderly, destructive yet creative. Plasma, matter in its fourth state, a conductor and a fluid all at once, behaves with a grace that resists simple equations. Flares teach us about the hidden architecture of the sun's magnetic heart, about the rhythms of stellar life, and about the connections that bind our star to the wider cosmos. To study them is to enter a laboratory too vast to control, too immense to replicate, yet endlessly rich in lessons, a laboratory not confined by walls, but spread across millions of miles. And yet, flares drift into our awareness not just as quiet lessons, but as soft reminders, like whispers carried on a gentle cosmic breeze. They remind us, in their hazy glow, of how delicate our human threads truly are, suspended beneath the watchful gaze of a star that never fully rests. A single flare can send a subtle ripple through Earth's upper atmosphere, stirring the quiet heights where satellites hum in their endless orbits, momentarily silencing the faint voices of radio signals, weaving confusion into the steady paths of navigation. A larger eruption, though rare in its depth, can brush against power grids with a sigh, dimming the lights of cities into twilight hush, isolating regions in a veil of stillness from the invisible networks we lean upon so trustingly. And an even stronger storm, possible yet distant in its dreaming, could unravel our global tapestries for days or weeks, inviting humanity to pause, to breathe, to reckon softly with its quiet dependence on these fragile strands of electricity and magnetism that bind our world together. This possibility settles over us like a soft fog, humbling in its gentle weight. It reveals how much we rest upon forces that slip through our days unnoticed. Like shadows in a dream, the shield of the magnetosphere arches above, a silent guardian woven from invisible fields. The intricate weaving of power lines hums below, threading through soil and stone. Satellites circle overhead in their lazy spirals, unseen companions in the vast blue, all of them, invisible, fragile, vital, like the quiet pulse of a heartbeat we forget until it slows. And yet, even as these flares murmur of hidden dangers, they also cradle reminders of beauty, unfolding like petals in the night. The very storms that send waves of radiant energy sweeping across the endless black also drape auroras across the sky, soft veils of green and violet that sway like silk in a breeze, waves of crimson and gold that curl lazily over the horizon, shimmering arcs that ripple from pole to pole in a slow, hypnotic waltz. To stand beneath an aurora is to surrender to the sun's tender touch upon the earth, to let your eyes trace the poetry of a star's restless dreaming. A storm that bloomed 93 million miles away dissolves into light that dances above us, a cosmic conversation etched in whispers across the velvet dark, inviting us to linger, to lose ourselves in its glow. This is the tender paradox of solar flares. In their quiet violence, they birth wonder, like thunder dissolving into rain. In their soft chaos, they paint beauty with brushes of fire and frost. They murmur of threats, yet they cradle inspiration in their folds. They remind us that the sun, though restless and veiled in unpredictability, is also lavish in its artistry, bestowing upon us glimpses of majesty that drift through no other path, no other dream. Let this truth settle over you like a blanket of starlight, warm and unhurried. And when we allow our thoughts to drift toward the sun in this way, it fades from being merely a distant ball of fire hanging in the sky, no longer just a clock marking the heavens or a lamp casting its glow over our heads. It blooms into something deeper, something alive with story. It becomes a storyteller, patient and eternal, weaving tales in the hush of space. Each flare is not a stray spark, not a meaningless flicker, but a carefully placed word in an unfolding epic, a syllable breathed into the void. Together, they murmur of magnetic fields twisting like vines in a garden, snapping with a sigh before releasing their hold, of rhythms that rise and fall across the languid span of decades, like breaths in a long sleep, of cycles that stretch not only across centuries but across the quiet lifetime of a star itself. They whisper of youth and age, of the wild, dreamy fury of stars in their tender beginnings, flaring with a reckless, youthful abandon that scatters light like forgotten wishes, and of the quiet restraint of older stars, glowing steadily as they drift toward the ends of their lives, their storms softened into echoes. Each flare is a syllable in a language of fire, a tongue older than humanity's first sigh, older than Earth's first cradle of rock and water. And we, with our satellites drifting like leaves, our telescopes peering through the mist, and our fragile imaginations unfurling like night flowers, are the quiet listeners, the ones learning to lean into the script of the cosmos, written in strokes of light that fade and reform. There is a perspective here that belongs to both science and humanity, two voices entwined like roots beneath soil, speaking in harmony through the dusk. Science offers us the gentle mechanics, plasma flowing like rivers of warmed honey, particles hurled outward at speeds that brush the edge of light, radiation unfolding across every wavelength like petals in a slow bloom. Humanity brings the deeper meaning, ancient myths of fiery skies that lingered in twilight tales, awe that pulls beneath shimmering auroras like dew on grass, a quiet concern for the fragility of our machines and the delicacy of our place in the grand hush. Neither voice drifts complete on its own, like a song without echo. To see flares only as veiled threats is to miss their soaring grandeur, the way they lift the veil on hidden splendor. To see them only as beauty is to overlook their quiet power, the depth that stirs the soul. In their duality, they mirror the duality of the sun itself, life-giver and gentle hazard, steady as a cradle's rock and restless as a summer wind, nurturing in its warmth and unpredictable in its size. And their influence does not linger only in the present moment, but stretches across the long, dreamy arc of cosmic time, like a river carving through stone. Solar activity has shaped atmospheres with patient hands, carved the destinies of planets in soft strokes, drawn the invisible boundaries of habitability with threads of light and shadow. Some worlds, orbiting violent stars that flare without mercy, may never whisper of life, sterilized by storms before a single seed can dream of root. Mars, once more alive in its youth, has been stripped bare by the sun's tempests, its air and water thinned away like mist at dawn, leaving behind a silent desert where winds sigh over empty dunes. Earth, by contrast, wrapped in its magnetic shield like a cocoon of quiet strength, has been sheltered through the ages, given the tender chance not only to endure, but to flourish in lazy abundance. Oceans that lap at shores in endless rhythm, forests that breathe in the hush of green, civilizations that unfold like stories told by firelight, all of them, in some hidden way, are children of that shield, protected enough to dream beneath a restless star, to let their thoughts wander under its watchful glow. In this way, solar flares are not merely passing storms, but gentle gatekeepers, impartial as the tide. Quietly, without fanfare, they decide which worlds can blossom with the soft pulse of life, and which remain barren and still, cradled in eternal silence. Let this thought drift over you, like a leaf on a stream, carrying you toward peace. To reflect on flares, then, is to surrender to a vast, unhurried dance, a dance of energy that begins in tangled magnetic knots, deep within the sun's dreaming core, ripples outward across 93 million miles of velvet space, brushes against Earth's invisible shields with a feather's touch, and blossoms into auroras that shimmer above polar skies like forgotten banners in the wind. From the delicate fragility of satellites spinning high above us in their silver dreams, to the myths whispered by ancient cultures who gazed at strange lights weaving through the heavens, the story of flares connects us to the cosmos with threads of light. It reminds us in its soft insistence that our existence is not separate from the universe's grand hush, but woven into its rhythms like a single note in an endless lullaby. And humbling, above all, is the timescale that enfolds us, vast and patient as a sleeping giant. Solar flares erupted long before there were humans to lift their eyes in wonder. They flared before the first forests spread their green sighs across Earth's waking skin, before fish drifted in shallow seas like silver thoughts, before continents wandered into their present forms in the slow dream of tectonics. They will continue long after we are gone, fading into memory's mist. They will endure as mountains crumble into dust on the wind, as oceans shift their ancient beds, as species rise like dawn and fall like dusk. And billions of years from now, when the sun swells into a red giant, its storms will soften and change, becoming chapters in a different book, the final languid chapters of a star's life, written in hues of crimson and gold. Yet for now, in this fragile middle chapter of the tale, the sun continues to flare, to storm, to speak in murmurs of light, and we continue to listen, our ears attuned to its quiet song, letting it lull us into deeper understanding. The rhythm of flares will drift on until the star's final fading days, a melody that hums without end. Our own encounter with them is only a brief moment of awareness, a fleeting breath in a story that began long before us in the universe's cradle and will continue long after, echoing through the void. And perhaps that is their greatest gift, a perspective that settles like dew, cool and clarifying. They remind us of our smallness, of the fragility of our machines that spin like fireflies, of the brevity of our lives like candles in the night. But they also cradle reminders of our capacity for wonder, for understanding that blooms slowly, for preparing with gentle hands. They show us that beauty can arise from chaos like flowers from cracked earth, that danger and grace can share the same origin in the heart of fire, that even the most ordinary sunrise hides within it, the truth of a restless star performing fireworks on a scale beyond imagination, fireworks that flicker and fade into dreams. As we close this journey, let your mind wander to the sun not as a silent sphere adrift in the black, but as a dancer in the grand hall of space. Its flares are leaps of light, arcs of plasma that curve like a lover's arm, sudden gestures of energy that ripple outward across the endless hush. Earth watches from its safe distance, both participant in the waltz and audience in the shadows, warmed by the steady glow that wraps like a shawl, and dazzled by the sudden sparks that scatter like stardust. The dance is ancient, ongoing, and eternal, a rhythm that sways without haste. And we are privileged to witness it, to let it carry us into rest. The sun's fireworks are more than passing storms. They are puzzles for scientists to ponder in quiet hours, wonders for dreamers to chase through twilight fields, reminders for all of us that our place in the universe is fragile, yet extraordinary, like a dewdrop on a spider's thread. Long after our voices fade into the cosmic wind, the sun will still be dancing, still flaring with soft insistence, still shining in its unwavering light. A star that never truly sleeps, carrying on its eternal story in the language of light and fire, inviting the universe to listen, to dream, to drift onward forever. And yet, flares are not merely lessons whispered from the cosmos. They are gentle reminders, soft echoes that drift into our awareness. They remind us of the delicate balance in our human world, cradled beneath the watchful gaze of a distant star. A single flare can send quiet ripples through Earth's upper atmosphere, like a dream stirring the air, gently disrupting satellites as they float in silence, softening radio signals to a hush, and weaving confusion into the paths of navigation. A larger eruption might send a deeper sigh across the planet, jolting power grids with a sleepy tremor, dimming the lights of cities into twilight, and wrapping entire regions in a veil of isolation from the invisible threads that connect us all through electricity and magnetism. An even stronger storm, though rare and distant like a fading memory, could unravel our global webs for days or weeks, inviting humanity to drift into reflection on our quiet dependence on these fragile ethereal networks that hum beneath our feet. This possibility brings a humble calm, a soft settling into awareness. It reveals how deeply we lean on forces that slip through our thoughts like mist. The protective shield of the magnetosphere arching high above, a silent guardian against the stars. The intricate weaving of power lines stretching across the land below, carrying whispers of energy, satellites drifting in their eternal orbits overhead, fragile sentinels in the vast quiet, all of them invisible, delicate and utterly vital, like the breath we take without notice, sustaining us in this dreamy existence. And yet, even as these flares murmur warnings of peril, they also unfold reminders of profound beauty, like a lullaby hidden in the storm. The very same tempests that release waves of radiation across the endless expanse also weave auroras into the night sky, soft curtains of green and violet swaying gently, waves of crimson and gold drifting like forgotten dreams, shimmering arcs that ripple over the poles in a slow, hypnotic rhythm. To stand beneath an aurora is to feel the sun's tender touch upon the earth, to witness with weary eyes the poetry of a star's quiet restlessness. A storm born 93 million miles away transforms into light that dances above us, a cosmic conversation etched in the velvet dark, inviting us to lose ourselves in its glow. This is the gentle paradox of solar flares. In their subtle violence they birth wonder. In their hushed chaos, they paint scenes of beauty. They whisper threats, and yet they inspire dreams. They remind us that the sun, though restless and unpredictable like a sleeper turning in the night, is also generous in its artistry, offering glimpses of majesty that no other force can bestow, wrapping us in a soft embrace of light and mystery. And when we begin to see the sun in this dreamy light, it no longer appears as just a ball of fire hanging in the sky, no longer a simple clock marking the hours or a lamp casting its glow over our heads. It becomes something deeper, more intimate, a storyteller weaving tales through the ages. Each flare is not a random spark, not a meaningless flicker, but a carefully placed word in an unfolding epic, a syllable drifting on the cosmic wind. Together, they speak of magnetic fields twisting and releasing like slow breaths, of rhythms that rise and fall across decades in a serene cycle, of patterns that stretch not only through centuries but across the vast lifetime of a star. They murmur of youth and age, the wild, youthful fury of stars in their early days, flaring with reckless abandon like dreams unbound, and the quiet restraint of older stars, glowing steadily as they drift toward the peaceful ends of their lives. Each flare is a note in a language of fire, a tongue older than humanity, older than Earth itself, ancient and soothing. And we, with our satellites and telescopes and fragile imaginations, are the ones learning to listen, to read the script of the cosmos inscribed in soft light, letting it lull us into understanding. There is a perspective here that blends science and humanity like two voices in a harmonious lullaby, woven together in quiet unity. Science offers the mechanics, plasma flowing like rivers of flame in a dreamy current, particles hurled outward at near-light speed like stars falling in slow motion, radiation unfolding across every wavelength in a gentle cascade. Humanity brings the meaning, ancient myths of fiery skies passed down through sleepy generations, awe beneath shimmering auroras that stir the soul, concern for the fragility of our machines, and the delicacy of our place in the vast quiet. Neither voice stands complete alone. They need each other like night needs day. To see flares only as threats is to miss their grandeur, their soft invitation to wonder. To see them only as beauty is to overlook their quiet power, their ability to stir the world. In their duality, they mirror the duality of the sun itself, life-giver and subtle hazard, steady and restless, nurturing and unpredictable, a balance that cradles us in its arms. And their influence does not linger only in the present moment. It stretches across the long, sleepy arc of cosmic time, shaping atmospheres with a gentle hand, carving the destinies of planets in slow strokes, and drawing the invisible boundaries of habitability like lines in a dream. Some worlds, orbiting violent stars, may never awaken to life, silenced by storms before it can take root, their surfaces left barren in eternal rest. Mars, once more vibrant and alive, has been gently stripped bare, its air and water thinned away by the sun's tempests over eons, leaving behind a silent desert where winds whisper forgotten stories. Earth, by contrast, enveloped in its magnetic shield like a soft blanket, has been sheltered, given the chance not only to endure but to flourish in dreamy abundance. Oceans that murmur secrets, forests that sway in the breeze, civilizations that dream beneath the stars, all of them in some way are children of that shield, protected enough to drift through existence under a restless yet kind star. In this way, solar flares are not merely storms passing in the night. They are gatekeepers, quiet and impartial, deciding with a soft touch which worlds can blossom with life and which remain barren and still, wrapped in eternal silence. Let this thought settle over you like a warm dusk, calming the mind as you ponder the cosmic choices made long ago. To reflect on flares, then, is to drift into a vast dance, a slow waltz of energy that begins in tangled magnetic knots deep within the sun's heart, ripples outward across 93 million miles, like a sigh through space, brushes against Earth's invisible shields with a tender graze, and blossoms into auroras that shimmer above polar skies in a hypnotic glow. From the delicate fragility of satellites spinning high above us in their quiet orbits, to the myths whispered by ancient cultures who gazed at strange lights in the heavens with sleepy wonder, the story of flares connects us to the cosmos. It reminds us that our existence is not separate from the universe, but woven into its rhythms like threads in a vast tapestry, lulling us into a sense of belonging. And humbling above all is the time scale that envelops us like a soft fog. Solar flares erupted long before there were humans to witness them, flaring in the quiet before the first forests spread their leaves across Earth, before fish glided through shallow seas in dreamy schools, before continents drifted lazily into their present forms. They will continue long after we are gone, persisting as mountains crumble into dust, as oceans shift their boundaries in slow waves, as species rise and fall like breaths in the night. And billions of years from now, when the sun swells into a red giant, its storms will change, becoming chapters in a different book, the final peaceful chapters of a star's life fading into cosmic rest. Yet for now, in this fragile middle chapter of time, the sun continues to flare, to storm, to speak in its gentle voice, and we continue to listen, our ears attuned to the whispers carried on light. Let this rhythm soothe you, like a distant melody drifting through the dark. The rhythm of flares will continue until the star's final days, a steady pulse that outlasts all. Our own encounter with them is only a brief moment of awareness in a story that began long before us, and will hum softly long after, like an eternal lullaby. And perhaps that is their greatest gift, perspective, offered in quiet tones. They remind us of our smallness, of the fragility of our machines that hum in the background, of the brevity of our lives that pass like dreams. But they also remind us of our capacity for wonder, for understanding, for preparing with a calm heart. They show us that beauty can arise from chaos like flowers blooming in the dawn, that danger and grace can share the same origin, that even the most ordinary sunrise hides within it the truth of a restless star, performing fireworks on a scale beyond imagination, a display that invites us to rest in awe. As we close this journey, imagine the sun not as a silent sphere suspended in the void, but as a dancer moving in slow, graceful steps. Its flares are leaps of light, arcs of plasma curving through space, sudden gestures of energy that ripple outward like waves on a tranquil sea. Earth watches from its safe distance, both participant and audience, warmed by the steady glow that cradles life and dazzled by the sudden sparks that light the night. The dance is ancient, ongoing, and eternal, a rhythm that soothes the soul as it unfolds, and we are privileged to witness it, to drift along in its flow. The sun's fireworks are more than storms passing overhead. They are puzzles for scientists to unravel in quiet contemplation, wonders for dreamers to lose themselves in, reminders for all of us that our place in the universe is fragile, yet extraordinary, like a delicate thread in a vast web. Long after our voices fade into silence, the sun will still be dancing, still flaring, still shining with a soft persistence, a star that never truly sleeps, carrying on its eternal story in the language of light and fire, inviting us to close our eyes and dream of the cosmos.